Mic test 1, 2. Should be clean. Testing mic 1, 2.
Yeah, sure. Okay. Do you want me to switch?
Welcome back, everybody. Hope you all had a good social last night. A big thank you to Africa Data Centers for sponsoring it and making it all happen. Sorry for the late start. There was a power outage. So we're all set to go. We have 3 talks on optics themes this morning. First up is Brian from Adtran. He's a systems consultant and has been doing this for about 15 years, so he probably knows a little bit. So, over to you, Brian.
Hi. So, I'm Byron from Adtran. so, official title systems consultant. I like to call myself a photon routing expert or a wavelength wizard, depending on what you want to hear the day. And so, my talk today is just to show everybody or demystify WDM. Because there's a lot of you guys that have networks in the field. I think this picture is pretty much normal to everybody. You've got your access technologies there, be it PON, business, Ethernet services, and you're aggregating these services onto dark fiber networks, which then eventually get aggregated onto metro networks, be it your own network or carriers or whoever. So what we're seeing happening currently is all these aggregations are happening on grey fiber networks or grey optics on dark fiber networks. So this becomes like a next top type of network architecture. You've got dark fiber, you're probably running 10G on it. I think most people in the room are running 10G at the moment. And or 100G services. So the idea here is this fiber is underutilized. It's not what fiber was meant to be. And I understand for most of the IP guys, fiber transmission seemed to be a bit of a dark horse, black box, whatever weird magic happens in there. And that's where I think me and the 3 other colleagues here today from Flex Optics and Smart Optics are trying to demystify and show you guys it's actually very simple. So what happens in these typical environments, like I said, it's dedicated dark fibers, nothing funny. It's one channel, and you're probably paying anything for a ring like this or a 3-node ring like this, you're probably paying 160,000 rands for the fiber over a 6-year course, right? The problem that happens is upgradability is an issue. Either you have to swap the boxes, buy a new fiber, like in this case where this operator had to upgrade to 20 gigs or an additional 10 gigs, so they had to buy another set of grey plugs and another fiber. So there's another 160,000 rand sunk across 6 years. So also shared bandwidth, you can't do anything with that layer. So what I'm here to show you guys is the wonderful world of WDM. So we talk about the battle of the bands. WDM has multiple bands that we can work within. So we have what we call O-band. It's a very low cost-efficient service. It's built for 5G RANs, typically for 5G frontal, because it's so cost-effective. The big issue is it has very limited reach. You cannot amplify these networks. They run up until 10 kilometers and that's it. Your scaling, you can only run 16 channels on this, and I'll tell you in a moment why channel count is very important. Then we get CWDM, so early days of wavelength division multiplexing, CWDM was the king. It's easy to set up, optics are cheap, built for access and aggregation networks. However, yet again, only direct detect optics, nothing funny. Low scaling up to 60 channels, and you cannot amplify these networks. So they're not built for the typical African market where fiber is not good. And I think a lot of you guys that have fiber have the issue of quality, especially in the metros. Then you get DWDM, dense wavelength division multiplexing. This is the cream of the crop. This is where everything's going at the moment. I mean, we're building optics that plug into routers that go straight into WDM networks. These scales to the full C-band, so you're sitting with 4.8 terahertz worth of spectrum. You can do multi-domain networks. This can be access, core aggregation, national long-haul, undersea cables, all that. You can run coherent optics on there, so 100 gig wavelengths, or currently we're running up until 800 gig wavelengths on systems. And the downfall on it is it requires some very precise management, right? So you need like GMPLS control plane, or as some of the vendors will call it, ASON. And it requires some technical skill set to operate and manage. And I think that portion is what scares a lot of people away from WDM. So what do we do? So I'm going to focus a bit today on WDM as a whole. O-band and CWDM are conversations in their own rights, but I think most of my colleagues will agree that WDM is the primary driver in transmission communications at the moment. So you've got 3 possible scenarios that you can run, and at the edge, it depends on the type of routing you're doing, the ease of use to customer and all that. So you've got what you have, dark fiber, and Matthias will actually touch on that today, or right after this, where you've got a dark fiber, like you would run your original setup, but you put colored optics on it. So you've got like a 100 gig ZR or a 400 gig ZR plug that plugs straight into your router, and that is the simplest. It's a day one solution, but you already have the base for WDM. It's a colored optic, so you can run within the spectrum. Yet again, it's just 1 fiber pair per service, and complexity in managing numerous links. So if you've got multiple links, that's how it's going to work. Then we get what we call fixed optical add-drop multiplexers. So these are passive WDM filters. I run 1 fiber pair on it, but you can run up into 80 channels. So that is already 8 terabits worth of traffic on a single fiber pair that you've purchased. Low capex, very easy to set up, no active equipment. The only active equipment is the chassis you manage. You've got fixed wavelength grids, so it's fixed slots of either 50 gigahertz, or 100 gigahertz, or in some cases 37.5 gigahertz. And you've got a fixed traffic matrix, so you've kind of got something static. You physically plug in these cables onto the filters or muxes, and it is what it is until someone goes there and changes cables around. Then we've got what we call ROADM-based, so reconfigurable optical add-drop multiplexing. So these are components that have, we call them WSSs. The most simplest explanation of it is it's a little silicone mirror in there. We pull some energy through it, and it changes its angular, it's an angular mirror, and it drops a specific frequency or picks up a specific frequency and routes it. So it's a photon routing piece of equipment, so it routes photon. Where you guys route IP addresses, we route photons. It's flexible, reconfigurable. You can sit in a NOC, create services. You just need someone to plug in the transponder or patch lead on the other side, and it runs. It's built for any baud rate, so you can run anything from 100 gig service per wavelength up into a 800 gig wavelength service. So 800 gig per wavelength on a 4 terahertz network, you can run up into 25 terabit on a single piece of fiber. So that's nice. And it's expensive. it's what it is. And I think when we go through this journey, everybody's going to at some point ask you, what's the cost? And we'll get there, and let's hope it's not as shocking to you guys as it is to most of our customers. So the idea is, in Access WDM, we have 2 models, like I already said. You've got, at the top, you've got what we call a mux ponder. So you take a layer 2 device. This is currently how it was done for many years. You take a layer 2 device, you take a grey optic, an LR4 optic or something like that, plug it into what we call a mux ponder. This mux ponder takes multiple 10 gigs, 32 gig fiber channel, 16 gig fiber channel, 40 gig E, and all these things. and puts it into a single wavelength as 100 gig, and you transmit your services like this. So it's an active piece of equipment. It is completely transparent. It does not look into any of the active IP headers. We just take IP information and we pack it into an OTM frame and we run it along in a RAID. The new school of thought and the new technologies that we're seeing is we're removing that muxponder layer, which is a high cost layer. So a typical muxponder layer, you're looking at anything between $12,000 to $20,000, depending on the muxponder, on 100 gig. We're removing that layer and replacing it with an optical layer, which runs anything between $3,500 to $4,000, also depending on the optic itself. And so we're immediately now cutting a cost layer in the access layer that was not there. So we're making this more accessible to the IP guys to start running transmission networks. So basically how that architecture will look is you've got your single fiber connected to the network. You're now running possible line capacity of anything from, so you can run 10G or 100G optics, and you can run any line capacity suddenly from 80 gigs up until 4 terabit line capacity on a simple system. Your optics can either be fixed or tunable 10 gig WDM direct detect optics. These could be 100 gig coherent WDM, 100 gig ZR, or 400 gig ZR. And your distance ranges now suddenly become up to 120 kilometers, in many cases unamplified if the fiber is good. Your client traffic add drop is layer 2, layer 3, which I think everybody in the room is comfortable with, nothing funny there. And your line traffic is layer 1, so pure OTN photonic routing. Your traffic protection is done at layer 2 or layer 3, so your typical Ethernet ring protection, if you ERP, if you want to do that, or whatever other technologies you use. So from the technology is you can take into your OLTs, stop doing this. You can take into your OLTs or customer CPEs or routers, you plug in these 100 gig optics or 400 gig optics, plug it into what we call a line filter or a MUX. So there's all those little colored blocks there by the routers. I think this does have a laser. Yeah. So you plug it into those little filters that we call MUXes, and you now can route your traffic next neighbor as much as you want to. Upgrading traffic is simple. If you've got a node, like that node that is a 10G node, but the past traffic on it has to upgrade to 100 gig nodes, but there's no considerable value in upgrading that node, that switch to now accommodate 100 gigs or something like that. You just upgrade the nodes that require it, and you can do pass-through traffic. So it's quite simple in that case where you can do that. You can ring protect this, so you can create proper rings that are closed. It doesn't just need to be a string network or a ladder, or I think there are many terms for that. And your capacity, you can run up to 40 times 10G, 100G. You've got shared backbone bandwidth, so if you've got a customer that suddenly wants to bring down their own kit onto the network, you just give him a colored optic, put his kit next to yours on the filter, and it goes along. Then what makes WDM a bit more better is you can do add drop and bypass. So it's not just typical next neighbor traffic where you have to go optical, electrical, optical again. You can bypass a node completely. So in this case, OLT at node 1, we bypass, and we take the traffic from node 2 to node 3 directly. So in a lot of cases, as your bandwidth demands grow, you want to hand off your traffic as quickly as possible, right? Latency is a bit of a killer, and everybody wants high-speed, low-latency networks, and optics does this for you. A typical optical WDM network will add, I think, Matthias could keep me honest here, I think in a typical WDM network, you should not see anything above 50 microseconds up to a millisecond of traffic, and this is optical to electrical conversion again. It gives you the same capabilities. You've got long-range communications. You can now bypass traffic, and it goes like that. So you're saving on fiber resources. Your cost is significantly lower when you start bringing on new services. It's a pay-as-you-grow model, so you can start with 1 channel, go up to 40 channels. In some cases, you'll hear today someone probably talk about FlexGrid, which is like super carrier, DCI, Terra capacity type stuff. And then your extra cost is just passive components and some power in nodes to manage those components. So that is the access layer. And the idea there is to really have something that is robust and small. So now the conversation starts is, what does this cost me? So if you're looking at currently 100 gig optics, if you're looking at buying an ER4 optic that reaches 40 kilometers, I think the fiberstore.com price, you're looking at about $4,000. If you're looking at ZR optics, QSFP 28 100 gig ZR optics, you're looking at probably $3,500 to $3,800. Sounds a lot, but now you suddenly have a colored optic that you can tune to a specific frequency on anyone's WDM network, and you can do up until 120 kilometers unamplified, where the 40 kilometer optic is a bit more expensive, and it's a great piece of kit. So now we've demystified, hopefully, the access side, and I'm just going to quickly touch on metro aggregation, because I think also that is something that needs to be spoken about. Is in the metros, what we are seeing is people building distributed routing infrastructure, right? So you've got your access networks, you aggregate the traffic there, put it onto a metro network where you're doing routing decisions again, and you're distributing this across your entire metro ring. So the idea is, like I said, is to have low latency, high capacity networks. So the benefit of WDM optics on these routers is you can take these optics now that you aggregate in your access network, and you can plug them onto high capacity mux ponders that take 100 gig and put it into an 800 gig channel. And you now get rid of an additional routing layer, and you just route your traffic optically directly to the core and break out in your core ISP nodes or your core routers, your MXs or whatever you guys are using at the moment, the Aristas. And then you've got the nice little end-to-end aggregation network that has the ability to expand from 10 gig up to 200 gig, 400 gig.
Currently, we use a lot of 10 gig optics in our passive DWDM.
Yeah.
But we're hitting constraints where, we've got, I think the biggest one we've got, is 12 channels. And the constraint for us is literally switch ports. It's the switches we're plugging into, we're running out of ports. And so we have 100 gig ports on our equipment, but we're struggling to find good information on what optics we can do there without having to go the active route. So we go the active route in certain places, but obviously that's quite a big investment and a big amount of infrastructure and all the rest of it. Where in some places we literally just could swap an optic using the existing muxes and move on. Can you give us an indication of where we're at in terms of passive, either at 25 gig or at 100 gig? What sort of distances? What are the options there?
So what we are seeing in the market is it's either directly take like 10 gig type of optics like you have at the moment, or we're seeing a big uptake in coherent traffic. So the idea of that is the colored optics have no range limit, theoretically, right? You can take a 400 gig ZR, and if the fiber is of good quality, you can transmit that at 200 gigs up until 1,000 kilometers with free amplification. In a typical metro access network, 100 gig coherent optics like the QSFPs, 100 gigs QSFP 28 or QSFP DDs will work in that space. The problem with 25 gig optics is there are no colored 25 gig optics. They are pretty much just gray optics. So the idea is, and also your cost is high because it's a weird rate. So for coherent, it's a good idea, especially if you've got QSFP 28 interfaces on your devices. Go coherent, and you can run and bypass traffic easily like that.
So you're saying that there are 100 gig one wave coherent optics available in QSFP format now?
Yeah. So commercially, there are commercially available, should be, most vendors are coming out of it Q2 this year. I know a bunch of beta versions have shipped and people are busy testing it. So the big challenge at the moment with those is managing the plug, right? So I think Matthias will touch on that after this, he'll touch on that a bit more. But QSFP 100 gigs are available.
Okay, so it's stuff that's kind of coming out of the factory now. It's not something that I should have expected to see in the market last year or anything.
No, it's coming out of the factory. It's brand spanking new.
Okay, cool.
Hi, my name's Andy Rabagliati. I'm a long-term member of the Internet Society. I'm curious about your silicon mirror switch thing. Okay. How fast does it switch?
So the limitation is not on the WSS wavelength. So it's called a WSS. So it's a wavelength selection switch. So it switches in nanoseconds. The challenge you sit with is if you've got a network with multiple legs on it. For argument's sake, you've got a national long-haul network that touches every metro and every national backbone, the NLDs, or some of the CCOM or fiber cables. Then what happens is your control backplane has to talk to each one of these nodes to figure out what wavelength is getting dropped where, what is the capacity, what's the grid size of it, and all that. So the switch itself happens in nanoseconds. The intelligence takes a bit of an unintelligent amount of time to figure out what's going on.
Hi there, Enrico, Coherence Technology Solutions. Could you just touch on temperature limitations of the various different optics that you mentioned? So the 100 gig coherent, the
So good question, right?
Yeah.
And I know why you're probably asking this because you probably have some street cake. Oh, sorry, apologies.
No, you want to repeat it.
No, he's asking the question.
Yes, I asked.
Yeah.
No,
So,
I couldn't make out your question.
oh,
That's
sorry.
why-
Sorry, just repeat that.
I was saying, could you touch on temperature limitations for the various different optical modules that are available in the market at the moment?
Yes. So I know why you asked this because you probably have a lot of street cabinet-based things where cooling is a challenge. So
Well, even in Terraco,
Yeah.
data centers, cooling is an issue.
So kit with typical WDM providers at the moment is anything from negative 40 degrees Celsius to 65 degrees positive. So you can run in these environments. Plugs typically range in the range of E-temp and I-temp, so industrial temperature. So this is uncooled DC or storage room, and E-temp for street cabinet capacities where you run that. The difference in the capacity is basically the heat sinks on the plugs, right? So if you've got for argument's sake, a QSFP 28 that sits in an environment that is a 6-watt power draw, that doesn't get hot. The photonic side gets hot, but other than that, we can run, or most operators or vendors, can run 65 degrees Celsius.
And the 100 gig coherent optics, are they more or less temperature sensitive than the standard
So
100 gig optics?
they're not temperature sensitive, but they are built to handle at those E-temp environments.
Thank you.
Awesome.
Great. Thank you very much, Bruce.
Thanks.
Next up is Matthias from Smart Optics. If we could have his slides up. So, he's going to talk about IP over DWDM. It's a good talk, I've seen it before. Rocco?
Yeah, thanks for coming. So it's pretty complementary to what Byron just said. So I will give you a little more insight into IP over WDM. It's a strong trend, but what is it about? So I will start with, let's say, the definition of what we understand when we talk about IP over WDM, and then why it's a strong trend. So it's not new actually, but the thing is, with 100 gigabit technology, there was no multicolored optics, as Byron also just pointed out, that was able to go, let's say, over longer distances in an efficient way without sophisticated amplifier technology and, let's say, pluggable optics in a form factor that wasn't well accepted in data center and, this kind of environments and switches and routers. So there are some challenges with IP over DWDM with the latest technologies, especially going to 400 gig, which I'm going to talk about, and then our experience with customers and technology so far, and some practical examples. Yeah, so IP over DWDM. Actually, when Smart Optics has been founded, the idea of founding the company was to take advantage of pluggable optics in host equipment and make it easy to build DWDM networks or CWDM networks at the time, like 18 years ago, for enterprise customers, data center customers, and that type of, let's say, applications. At that time, not focusing on the carrier market, more on the enterprise market. But yeah, what is? Yeah. Yes, thank you. So what is IP over DWDM? First, it's the animation doesn't work, right? Use let's say gray optics in a router connecting to a muxponder or transponder, as Byron has also just pointed out, and convert into a DWDM signal. And these were typically fixed lasers on the transponder or muxponder, or CFP2 or CFP4 modules that are interconnecting with the DWDM layer of the network. So that could be done with 10 gig, 100 gig, 400 gig, multiple 100 gigs. So that's why we have these flavors of transponders and muxponders. However, with that technology, I mean, there's a lot of overhead in equipment that is not necessarily needed if you don't need these transponders and muxponders for demarcation or for, let's say, more efficiency and traffic aggregation. So the idea of today's network is to just plug the coherent, tunable DWDM optic straight into the router and take advantage of the technology and save complexity in the network and these kind of things. So with today's technology, it's, let's say, possible to just use an open line system vendor for the DWDM network, for multiplexing, amplifying, and let's say routing the waves with a pluggable DWDM transceiver that sits directly into a switch or a router. And I mean, why is it so attractive? One thing is, of course, cost savings. And the second thing right now is also lower power consumption. So power in data centers and cooling in data centers is actually a big problem with the high density of, let's say, heat dissipating components today, servers, routers, DWDM equipment, all consume a lot of power. And together with that, it's also less space, it's lower latency, because with the less OEO, so optical conversion we do, the less latency we have. And it also goes in line with lower complexity of actually building the network. And yeah, what allows all this is, especially for the higher data rates now, is the introduction of these 400 gig ZR and ZR plus pluggables in the QSFP-DD form factor, which are very common in data center switches and routers that everybody's using today. So CFPs and CFP2s were there before, but not common in data center equipment. And another thing which goes in line with, let's say, this trend is, in the past, the DWDM networks have mainly been designed around telco requirements for long-haul networks, for national backbones, for metro backbones, where service providers were actually making the connections for enterprises, for data centers, for cloud providers, interconnecting, let's say, the data centers, the metros, and the world. These days, most of the traffic is actually driven by the cloud providers, by the data centers, by large enterprises, and content providers. So many of these data center providers and cloud providers have started building their own DWDM networks. So they are leasing their own fibers, or they are even laying their own cables And they are now taking advantage of, let's say, building leaner DWDM networks for their own use. Yeah, so that's what we're seeing right now. And with these standards, I mean, there are also coming some challenges. So one is 400 gig ZR is an ORF standard, which has been developed more or less for data center interconnect. So it's well-defined in all aspects with regards to distance, optical power levels, interfaces, and so on. So it works perfectly for distances up to 120 kilometer in the metro to interconnect data centers. Power budget is a bit limited. 11 dB doesn't allow you to go that far. So you might still need amplifiers, but it's a robust and very performing technology. 400 gig ZR Plus is not really a standard, but it's an MSA that many vendors support. And it goes a little bit beyond 400 gig ZR, so it defines electrical interface and transmission standards that can be used, again, in a QSFP-DD form factor in a switch or router. And yeah, the complexity there is there's an open ZR Plus standard, an open ROADM standard, and some, let's say, vendor-specific standards like OpenXR. All together have the same idea in mind, bring this, let's say, sophisticated technology into a transceiver and make networks more, let's say, performing and more, providing more bandwidth. Here, I just pointed out one point. There are so many different CMIS versions. So CMIN is a Common Management Interface Standard for QSFP-DDs. And in order to support these complex tunable optics in a host switch or router requires actually firmware support in those devices. So in the early days of DWDM, it was pretty easy to use a 10 gig DWDM pluggable in any type of switch or router, and it just worked. With the QSFP28s, it got a bit more complicated. With QSFP-DDs, it's even more complicated. So the QSFP-DDs are almost a transponder in a pluggable, so it's a complete optical subsystem that has a lot of functions these days that are required to be supported in the software of the host. So innovations around coherent pluggable optics that are just happening right now. The first two generations of optics, so coming back to 400 ZR and ZR Plus, had a little, let's say, drawback, which was the low output power. So they were good in amplified point-to-point networks or in networks that were designed to support these optics. Recently, we got the high power of 400 gig ZR Plus to market, which comes out with 0 dBm output power. So that's way better to be supported in existing DWDM backbones with, let's say, ROADM networks, ROADM-based networks that were designed to take CFP, CFP2 signals or 10 gig signals that came out at around 0 dBm power level. So that's pretty good. These also have a 200 gig 16 QAM mode that I come to in a minute, supporting 50 gigahertz grid networks. So otherwise 400 gig will require 100 gigahertz. Yeah, I do. So the next thing we are seeing now is open ROADM pluggables. Those are not yet there, but coming almost every month. So they are adding layer 1 encryption, and they are also adding indent management capabilities and OTN support. So those will take this, let's say, embedded approach to the next level. And with enhanced DSP technology, there will be also, let's say, new modulation formats coming up, like probabilistic shaping to optimize a modulated signal for certain applications, subcarrier technology, so transmitting multiple carriers in the same DWDM channel to increase bandwidth or to optimize performance for longer distances. And what we are seeing right now is that 800 gig pluggable coherent optics will come probably end of this year. And I mean, there are two things. Either we increase the baud rate, keep the modulation format, and get higher speeds, or we keep the, let's say, baud rate, use a better modulation format and extend distance. So there's always a drawback of, let's say, higher data rates or longer distance with these pluggables. But it's all going to higher speeds and longer distance overall. One thing which is quite important is these 100 gig QSFP28 coherent modules coming to market now. Byron already talked about it. So that will bring 100 gigabit DWDM embedded optics for almost all switches, routers, OLTs, DSLAMs that are supporting QSFP28 optics and allow customers to build that type of networks without transponders or muxponders in the access. Yeah, or even in the core, but metro core. So looking at 400 gig, there are 2 or 3 challenges, I would say. One is the bandwidth of the modulated signal of a 400 gig signal is around 60, what did we say here, 63 gigahertz, 65 gigahertz. Many old days DWDM networks are using actually DWDM filters that have not been designed for this passband. So upgrading an existing ROADM network with 400 gig requires a couple of things. One thing is to make sure that the ROADMs or the filters, the dispersion compensation modules are actually good to take these signals and to transport these signals without seeing penalties. If 400 gig doesn't pass through in some applications, 200 gig 16 QAM might be an alternative. So it's a smaller bandwidth, which is almost in line with the 100 gig QPSK signals and allows you to run 200 gigabit over your network. Yeah, the next thing is the power levels. I already mentioned 400 gig ZR and ZR Plus had pretty low output powers, so like -6 to -13 dBm. So those require, let's say, either preamplifiers before you enter a ROADM network or a network that has been designed to take these signals. With the high power optics, we are more or less solving that problem. So we have a couple of customers that are running 400 gig ZR high power over their existing ROADM network without any problems. So I think these are manageable challenges if you know what you're doing. OSNR, of course, is another thing, but these are all things that are, let's say, doable. Our experience so far is in point-to-point networks, 400 gig ZR and ZR Plus, is already there. So we are deploying point-to-point networks day by day, more or less, internet exchanges, data center interconnect, and all these applications are working very well. The acceptance of ZR and ZR Plus optics in switches and routers is there with most of the, let's say, big vendors that are providing 400 gig equipment, and amplifiers can solve it if 400 gig ZR Plus optics with high power are not supported yet. In existing ROADM networks, there are the challenges that I already mentioned. So we have the first project already installed. There are greenfield deployments happening right now. So the service providers that are just starting to build their networks, have one advantage. They can just take on this new technology and build a network that is optimized for IP over DWDM with 400 gigabit coherent optics in their host systems. The adoption of IP over DWDM in existing networks is a bit slower than expected, and the main reason is that the switch and router vendors are lacking a bit behind with support of these high power optics. So as I said earlier, there's support in the firmware required in order to run these optics embedded in a switch or router, and that's not really there yet. So we are doing lots of trials and qualifications with system vendors as well as with service providers and enterprise customers to test what's possible and where are the limitations. So, practical example, let's say for a point-to-point DCI link. It's an open line DWM system connecting two sites over dark fiber and a coherent pluggable in a switch. And one drawback in the past with IP over DWM was always it's hard to manage. But with these, let's say, optics today, they provide all the optical parameters that are required to judge if an optical link is actually performing well or not. So in the past, we just saw transmit and receive power, and that's it. With today's optics, we can actually see prefect bit error rate, we can see OSNR from most host systems, and that gives us a very, very good, let's say, measure of the quality of the link. And we could even get early warnings when the layer 1 isn't performing well. If it goes even worse, layer 2 or layer 3 will be affected as well. So we can basically monitor the fiber, and we can monitor the in and outgoing signal on the open line system, as well as in the switch, which means we have end-to-end monitoring for every service through our DWM network. So that's pretty easy and not complex at all, and brings DWM basically to every customer, even if they don't have vast experience with that technology. This is an example of a CLI output from a Juniper router. So here you also see that we get all the information about the optical layer, about the operations mode. They can run in 400 gig mode, 300 gig mode, 200 gig mode, 100 gig mode. So the lower the data rate, the better the performance over distance. And there's also statistics available about prefect bit error rate, OSNR power levels over time. So you get a very, very good visibility of the performance of your DWM signal. The same thing can be done on a ROADM network these days. So there's not really a need to have all these complex transponder-based solutions. If we run it in a ROADM network, we can actually simulate 400 gig services, 100 gig services with different type of transceivers. So here it's a high power 400 gig transceiver according to OpenZR+. And we can simulate the service end to end through an ROADM network based on OSNR values from the network, distances and power levels. So you know from your planning tool already if a service is feasible to be deployed or not. And once it's deployed, you also get on a ROADM network all the information from the endpoint of the service terminating at the ingress and egress of the network. So you get a full service visibility in an open ROADM network or in an old ROADM network with these embedded optics. So that's my last slide. Thanks for your attention, and
thank you very much.
Any questions?
Do we have any questions? Not a question.
It's me again.
Hello again.
Graham from the internet. So you were saying that the management in the coherent optics is giving you the same stuff that we've had previously from the transponder systems. Is it complete feature parity, or is it like most of the stuff?
I mean, yeah, it depends what transponders you worked with before, but I mean, the most important parameters are typically input, output power, OSNR, prefect bit error rate, and these kind of things. I think I forgot his name. Flex Optics guy will go a little bit deeper into the details of the monitoring capabilities of the 400 gig optics. So he has way more details about that. I just wanted to point out that these, let's say, base layer 1 parameters are available in, I think, every core router and switch that I'm aware of right now.
Okay, so that was going to be my second question, is the capability is dependent, as you said, on the firmware, and what is the availability across the different vendors right now? Is it kind of everybody's there, or are there people lagging?
I mean, I can just name, let's say, the vendors that we worked with so far. It's Juniper, Nokia, Cisco, Arista, Huawei. To my knowledge, all of them are presenting all these parameters in their host systems right now. And I expect that to be, let's say, common across the board, because otherwise carriers and cloud providers, data center operators, even enterprises wouldn't accept this technology if they don't have the right, let's say, visibility of the optical parameters in the network. It's essential to run an optical network to have these performance parameters.
Yeah, no, I agree completely. I mean, we have some challenges with some of the fiber quality in the country at the moment, and we are finding that we have to have that visibility, otherwise we can't fix issues.
And I mean, just in case that the host system do not have all these parameters, I mean, transponders are still there. So we are just saying, use this technology where you can, but if a transponder or a muxponder is adding value because you're increasing, let's say, the capacity of an optical channel through your network, yeah, use a muxponder. If you need a demarcation in order to hand over to a long-haul carrier, use a transponder. And with the open ROADM features of the next generation of QSFP-DDs, where we will also get layer 1 encryption, I doubt that the router and switch vendors will implement firmware support for encryption very soon. So if you want encrypted layer 1 services, I mean, that might be also a feature for a transponder, adding value at the same time as having a demarcation.
Hi, Andrew Dolgan, Nokia.
Sorry, could you say that
Hi,
again?
Andrew Dolgan, Nokia. I would ask you to be careful about what you state about what vendors do. On our routers, we support this. We've been supporting the 400 gigahertz for quite some time. We do interoperate. You showed Juniper. We do interop with them. We manage this end-to-end. We do have encryption at full rates on any levels in hardware. So let's kind of stick to what we do and not pass what other vendors do. I'm not going to go and defend other routing vendors. If they hear, they would come and probably defend themselves. But from Nokia perspective, this is a definitely good technology. We do support it. It's being deployed. The quality of the fiber is a problem.
Yes.
I'm not a layer 1 guy. I'm an IP guy, but I know the quality of the fiber is a problem, especially for a distance. But it's definitely good technology.
Yeah, I mean, I would totally agree. I mean, the physical, let's say, boundaries are the same for all vendors. So we can't overcome high losses and poor, let's say, fiber network qualities with technology, at least not just to a certain extent. And yeah.
Got a couple more questions, if you don't mind.
Yeah,
we're making use of some Alienwave services from other carriers. Is that functionally equivalent to what you were referring to as the open line system?
Yes, absolutely. I mean, that's the whole idea of having an open line system, that it supports third-party waves through the network. And I mean, there are different approaches to that. Some vendors, I mean, have it implemented as, let's say, open from day one. Some vendors have their license models. Some vendors have design tools for open, let's say, alien wave services. Some vendors make it a bit more complicated. But I think the trend to request alien waves through a third-party ROADM-based network, or even a multi-vendor ROADM network, is definitely increasing with this technology right now that the pluggables bring to market.
Yeah, we currently have IP device, a standalone box doing a transponder, and then it goes off into the network. And so this theoretically means you can put a pluggable into the IP routing device and eliminate the transponder if it's not serving a purpose. And then the last question I had was we use a lot of this kind of stuff in our access aggregation, so at fairly short distances. And you mentioned dispersion control, and I haven't been able to find good information on this. Can this kind of stuff work without dispersion control or dispersion compensation when you're talking about like 10 to 40 kilometer ranges? Where does dispersion compensation become important?
So the dispersion compensation with coherent modulator optics is basically taken care of in the coherent modulation. So the ZR optics are specified to run up to 120 kilometer distance with regards to dispersion. The ZR plus optics go up to like 450 kilometers. And that's actually also the reach that you can expect from a 400 gig ZR plus optic with amplified links. So 450 kilometer might sound like a dispersion limitation, but when you are going 450 kilometers in an amplified network, you're already hitting the OSNR limit anyway. So 450 kilometer right now, I think, is the ZR plus limitation. But with lower data rates, you can go even further. And when the 800 gig optics will come to market, they will come with 800 gig 16 QAM modulation, or alternative with a 400 gig QPSK modulation. So that means with 400 gig QPSK, you can actually take a 400 gig signal to like 1,000 or maybe 2,000 kilometers, because the OSNR is just way better. The drawback with that is that the 400 gig modulated signal will require even wider band. So instead of like taking 65 gigahertz, it will probably take 125 gigahertz or something like that, because the baud rate is just doubling, and with that, the spectral will double as well. I mean, another way to optimize OSNR for 400 gig is Raman amplification, but with bad fiber networks, Raman, I mean, doesn't really help a lot. It can help to lower OSNR, but it cannot help to overcome high fiber losses.
Cool.
Yeah, thank you.
Thank you for all those questions. Perfectly on time for 10:30.
Yeah,
Thank you, Matthias.
So, well, thank you.
Thanks. Next up is Thomas Weibel from Flex Optics. He's going to talk about coherent optics, how they work, scary physics, but pretty pictures. Is that a good description?
Perfect. Thank you, Fergus. Yeah, my name is Thomas Weibel, co-founder and CTO at Flex Optics, and I really like this lineup now. Actually, it's not a talk now, and together with Matthias and Byron, we didn't know that we are in this lineup. It's like a DWDM workshop for you guys now, in a nutshell. Thank you. So this perfectly fits as well now about coherent optical transceivers. Byron and Matthias mentioned it already. So this talk is mainly split into two sections. It's a little bit about theory, no worries. Maybe there is an exam, no, there is not an exam at the end. And then some practical experience, especially for Nokia. Where are you? We did some practical workshop with Nokia together and integrated coherent transceivers in the Nokia gear and showed the output, how Nokia implemented it. So where are we coming from? 10 years ago, roughly, let's say, DWDM has been around for a long, long time. But the challenge there was big cards, big transponder cards, and to get out the light of the transponder card. What is so special in those transponder cards? There is a chip called DSP, the digital signal processor, which actually enables coherent DWDM technology. Now, moving towards 400 gig, the biggest challenge was there to make it really small, especially the digital signal processor, to produce it in a small, nice way that we can squeeze it into a form factor like a QSFP-DD. And today we are able to do 7 or even 5 nanometer chip productions, and for sure the smaller the grids inside of the chip, the smaller the entire housing gets. So the DSP is now inside of the coherent module, and that's actually the game changer. So a coherent module, or let's say the coherent technology, for me personally, it's really a game changing in industry, and I will show why later on. So let's first of all start with where we are coming from. Direct detection, that's, let's say, typical on-off keying method We have what you see here on the upper left diagram. It's a typical rectangle shape of 1 and 0 signal at the end of the day, or state, and representing one symbol. And on the lower one, actually, that's basically how it looks like when it hits the receiver. So it's not a rectangle, perfectly shaped signal any longer. It's going to be more a sinus wave form, or even some other artificial thing. Now, if we would use the techniques which we have done so far, just increase the frequency, the diagrams would change slightly. So the rectangle shape is just getting narrower and narrow, and the sinus form is getting narrower as well. But also the light levels or the power levels are getting way harder to distinguish between a 0 and a 1. And if we increase it even more, you can imagine for the receiver on the lower one, it's getting really hard to detect what is a 1 and a 0. I think it's even hard for you guys to detect where is the 1 and where is the 0.5 on the screen. So beside higher frequencies for light, light has way more properties, and that's what I want to talk now about. So beside the amplitude, we also have phase and polarization. And let's start with the polarization. Quite a lot of you here in the audience use a privacy screen on your laptop, and actually that's a polarization filter. Or if you wear sunglasses, they also filter certain polarization directions. For Korean pluggable, we make use of 2 polarization directions. Typically, it's going to be used the Y plane and the X plane. And with these 2 polarization planes, we can encode actually double the amount of data. So how does this look like? I do have here now a 16 QAM modulated. To the 16 QAM, I come later on the Y plane. And on this, the same signal on the X plane looks a little bit different. It looks like this. And now when you combine those 2 planes together, and we are living in a 3-dimensional world, your actual signal looks like this. This artificial sculpture that's going to hit the receiver, and the receiver is going to differentiate there between the 2 polarization directions, and also calculates the 0 and 1s out of the signal. So beside the polarization, I already mentioned it, it's the 16 QAM. And what is the 16 QAM stands for? So QAM is quadrature amplitude modulation. It's a modulation scheme, and we make use of complex numbers. So what you see here is a 4x4 matrix with 16 dots, and on the x-axis, it's the in-phase component, the real part. In comparison, have a look at PAM4 modulated signals, or the NRZ, which is the green square or the blue star there. There is only the in-phase component. So with NRZ we have 2 states, or 1 bit per symbol. With PAM4 we have 4 states, or 2 bit per symbol. And with 16 QAM, at the end of the day, if you do the math, we have 4 bit per symbol. And in the real plus now, the imaginary part, and that's a phase shift. So we shift the phase by 90 degrees. And so that's how you get this matrix. A little bit of a real-world example, and some of you might know this. This is an optical rotary encoder. It's going to be used in servo motors to find the position at the end of the day. And how does this work? So this sliced disk is turning around with a certain frequency, and you have 2 detectors. And as I showed there, the lower one is the real part, and then a little bit physically moved with a little bit distance, there's the imaginary part. But now the important thing is we sample at the same time, always. And then just due to the fact that we sample at the same time and this disk is spinning around, we get a signal which looks like this, and it's phase shifted by 90 degrees. For sure, within a coherent transceiver, there are no spinning disks. It's done a little bit different, but that's actually how we enable a phase shift in the real world, just with that spinning slice disk there. So this was about the modulation itself. So we covered polarization, we got details about QAM, and now an important measurement is the signal-to-noise ratio, or OSNR called. What is it about? It's actually just a ratio between the actual signal plus the noise. And a good comparison is within that audience, you are on a really low noise level because you can hear me, hopefully, quite clearly and easily. And so we have a high OSNR ratio. If I would do the same talk in a cheering football stadium, I think it's going to be really hard to understand me, and the noise level is really high. So that's basically what also happens on optical networks. You really need to take care about a signal-to-noise ratio, otherwise the receiver is not able to detect it any longer, what's the actual signal is. And now coming back to our constellation diagram, which I introduced previously, how would OSNR look like on the constellation diagram? So we do have, on the left side, you see an SNR of 30 dB. And the dots are really easy to identify there, the 4x4 dots. Pretty easy for the receiver to detect. Now, going towards to the right side with an SNR of 20 dB, it's getting a little bit blurring already, but still possible to detect. But now looking at the SNR of 5 dB, this is like though it's not possible to detect any longer which bit belongs to which matrix section basically. And the receiver is not able to distinguish between 0 and 1s, so not possible. So it's a really low SNR here. Okay, so that's the theory part. Now let's move on. What we did last year together with DKIX in Germany, they are running quite a lot of Nokia gear. We basically took a 400 gig coherent transceiver, plugged it into their gear, and looked how Nokia implemented it with the SROS. And we just run one command. It was the show port command, and I will go through it now step by step, what we see there, what is new basically compared to gray optics and traditional transceivers. So at the show port, these are basically 3 sections, and the first one is mainly, characteristics of the transceiver itself. It's a fully tunable 400 gig coherent transceiver, and you see also the start and the stop frequency. Here it's shown in megahertz. Typically we use terahertz because the numbers are a little bit smaller, or channels. So this is 191.3 terahertz up to, and it's tunable up to 196.1 terahertz, or easier, channel 13 up to channel 61. The tunable is currently tuned to channel 23, and it does support a couple of grids, the well-known 50 gigahertz and 100 gigahertz for sure. Moving on, yes, we still have not DWDM, that's what we have, but we also have diagnostic monitoring. It should be known by now from quite a lot of you guys, and hopefully you have implemented in your network management system to monitor the diagnostic values. And I want to point out, typically TX and RX is for sure, we know the power levels, but I want to point out the temperature. In the optical industry, we are actually more heat generator than optical industry. So the whole power you feed into a transceiver, which here is roughly 17 watts, is mainly converted to heat. So let's say it's 16.999 watts what we generate on heat, and only a really small portion on light is coming out. So the actual light level of 0.001 watt, which is 1 milliwatt, or if you do the calc, you get 0 dBm. So that's our ratio. So actually we are not optical, we are a heat generator. And now bear in mind, if you have a 32 port switch with providing 17 watts on each port, this is more than 500 watts just for the optical components. We have seen vendors out there who say, okay, this is quite a lot of power. We first of all have to generate that power in our power supplies and feed it to the ports. We enable the high power mode. That's what they call it, a high power mode for the QSF PDD port. But then we disable every second port. So your 32 port switch is at the end of the day a 16 high power port switch. So this can happen. So look in your data sheet and just ask your vendor, hey, do you support high power ports? Now coming to the coherent specific parameters, And Matthias already pointed it out. Juniper did some implementation there, and now we're looking at the Nokia's implementation. Arista did something there, and they're pretty much around the same. Yeah, I'll go through now step by step. So the first one is the RX channel. This is quite new. Before 10 gig DWDM's traditional networks, tunables need to be tuned on the TX side. We still have to do this for coherent ones, but also we have now to set the RX channel that the local oscillator is locking on that frequency inside and knowing, okay, how to get rid of the carrier. There is no sweeping, so we can't detect the channel, so you need to know on which channel you're transmitting and receiving. Moving on there, dispersion was mentioned already. We have now two types of dispersion. So the first one is the chromatic dispersion. So what is chromatic dispersion? It is the change of the signal while it's traversing on the fiber, on its way actually from the transmitter to the receiver. And the longer your fiber is, the more your signal is be either extended, stretched, or pushed together. The DSP is quite powerful. It can compensate it. So it does it with some really fancy math to compensate the chromatic dispersion. And here you see in the positive way up to 2,000 picoseconds down to minus 25,000. But the more challenge is the positive one to compensate than the negative ones. And plus, you get a measurement device. So the chromatic dispersion is measured now actually in real time. So this is 220 picoseconds per nanometer. When you know the characteristic of your fiber, and we had here a G652.D, which has roughly 10 picoseconds per nanometer per kilometer, and you do the math, you might end up with 22 kilometers of fiber, which is not true. We ended up with 15 kilometers because we knew it's a 15 kilometer span. And we wondered, hey, where is those 70, 80 picoseconds per nanometer coming from, this offset? So we did a back-to-back test, just 2 meters of jumper cable, and ta-da, we had 80 picoseconds. We didn't know where it's coming from. There is an idea, maybe it's coming from the plugs, but we are not quite sure at the moment. So there is an offset. So the actual fiber was 15 kilometers. Beside chromatic dispersion, as we have now two polarization directions, we do have a polarization mode dispersion as well. And this is, here Nokia implemented it as different group delay. That's actually how both planes, so the Y plane and the X plane, are different with each other while they're traversing on the fiber. Here we measure 2 picoseconds, which is still in range, and the transceiver or the DSP, it can compensate up to 10, depending on what we are following. Up to 20 picoseconds, it can compensate it without any issues. I mentioned issues, and issues are always measured for the bit error rate. So here you see the prefect bit error rate. Typically, we see it here, the prefect, which is entering before we go to the FEC. What is the FEC? It's the forward error correction. And this is also part of the DSP to correct errors, not only to detect, but we can also correct them. And this forward error correction is quite powerful, but it has limits. And the limits are shown as the RxQ margin. Nokia was quite creative there. We couldn't find the Q margin in the other industry around, in the optical transmission. Typically, it's called the Q factor. And what is the Q factor, the Q margin? How much gap is there still that the forward error correction is still able to correct errors? So if this margin is eating up to 0 dB, then the forward error correction is not, it still can correct errors, but on the post-FEC side, we will see more and more errors showing up. And then the upper layers, layer 2, layer 3, they will see this also in a bad transmission or a bad link. And it can turn out to a flapping link, for example. A back-to-back link had a margin of roughly 4 dB, so there was a lot of margin. And for sure, OSNR is also an important thing. Now on 2 polarizations again, we were running those 15 kilometers at 34 dB, pretty well, pretty good. We can go down to 26 or 24 dB of noise level, and if you go below for sure then your prefect error rate will go up again. So you need to take those values always in consideration and watch your prefect error rate precisely. That's an important outcome here. Just need to check where we are on time, because Matthias mentioned, we're good. Matthias mentioned a little bit about application modes at the beginning, and yes, that's pretty amazing. The coherent modules, this is not only a just 400 gig module, it can also provide different application modes. Here you see 15 different, it's a little bit tiny, but the easiest one is like, let's say you can make 2 by 200 gig interfaces out of this coherent, or a 4 by 100 gig, and even weird mixtures. That's pretty cool. What you see here now, I highlighted the OpenZR Plus OFAC. Actually, that's how we configured it, but the module was not capable to do it. So this was an OIF-based module. It's not capable to do the OpenZR Plus MSA or following it. So you need really to double check your data sheet. What is your coherent module capable to do? And how you configure it in your switch, because there are different settings. And what is the difference there? I pointed out the optical parameters of OIF versus the OpenZR Plus MSA. So and yes, for sure we have TX and RX levels. And on the OpenZR Plus, there is even more variation. They call it the 60L for low A version and the 60H for high power A version. And they typically differentiate there on the TX side, how high the power level is. But the interesting part is more on the, what I pointed out about dispersion and the OSNR tolerance. And there you really see that the CDR, chromatic dispersion tolerance for the OpenZR Plus is way higher compared with the OIF ones. And this also explains why you can, for example, use the OpenZR Plus for more amplification, for example, longer distances, longer spans, and even the polarization mode dispersion is more tolerant here. Brings me almost to the end of the presentation. To summarize this, and I mentioned at the beginning, the DSP inside of a transceiver is now, in the small form factor is, in my point of view, a game changer, because we can just, with raw and pure compute power, increase the bandwidth. And I'm pretty sure we will see this also for 800 gig or even beyond for 1.6 tera or even above. There are a lot of discussions ongoing, because the other method to increase bandwidth is to increase the frequency on the electrical side. And we are currently running at 50 gigabaud already, which is fast. And 800 gig will move towards 100 gigabaud, which is even double the amount. It's really, really fast, because you still have to sample it. 100 gigabaud sampling is not that easy. You need special materials on the PCB as well. But with the power of the DSP, you even can quadruple or even 8 times make it way faster, which I showed here on this graph. This brings me to the end of the presentation. I'm really happy to take more challenges in terms of how did other vendors implement the coherent transceivers in their layer 2, layer 3 gear. So we did it with Nokia so far. We had a lot of fun at that workshop. It was really cool. And if you have gear and you want to see how the coherent modules are integrated in your gear and how it works, drop us a line. I'm really happy to take it. Thank you very much. And for sure, I'm still around for questions.
Thank you, Thomas. Any questions for Thomas? Well, you're here today and first thing tomorrow morning?
No, tomorrow afternoon.
Okay, okay.
Afternoon, yeah.
Thank you very much again, Thomas.
Thank you.
Ed has 2 quick announcements, so I shall hand over to him. And
bright light. Hi, everyone. The couple of things. There's T-shirts now available at the inks desk in the reception area, those who put an ASN on their shirts, those who entered an ASN on their order form, there's most likely one pre-printed for you with your name and your ASN on the shirt. So you can just go and collect it from Faith at the inks desk. If you didn't register and provide your ASN, but you do have an ASN, you can also go and see Faith and she can issue you a shirt. For reference, it's a shirt like this one on the back, which I think is quite cool. If you don't have an ASN, you can get a shirt, but they won't embroider it for you because it's specifically aimed at the pairing people. And yeah, Faith is basically next to the coffee cart in the reception area, next to the Equinix cart. And then, yeah, just a reminder that other vehicle that was parked sillily, I've now forgotten its number plate, give me 1 second. I think they're still trying to get it to move. It's the Volkswagen SUV LG95GN GP. So if that's your car, please go move it before they tow it. Yeah, thank you. And I think it's now tea time. So we'll see everyone back here in about half an hour. can have a seat, it would be great. Thank you. Toots. Good afternoon. No, not quite afternoon. Good morning, everyone. Just running a little bit late, so apologies for that. Our next speaker is one of our remote talkers, remote speakers, a gentleman called Jeff Houston. If you've been in the industry long enough, you've probably heard him speak somewhere or watched a YouTube video that he's presented on. We saw this talk in Bangkok about 2 weeks ago and thought it would be a nice fit for this session. And just speaking about sort of where the IPv4 where the IPv4 world is going at the moment in terms of what we see in the BGP world. We should be able to have him on afterwards for some questions. We were just having an issue with the Zoom a bit earlier, so if we don't have a gap for questions, apologies, but yeah, we'll get the video rolling now. Thank you.
Good morning, good afternoon, whatever it may be. Hi, my name is Jeff Houston. I am the Chief Scientist at APNIC, and I'm sorry I'm unable to actually make it over to South Africa for ZANOG today. Planes, budgets, ticket costs, blah, blah, blah. So it's virtual me doing this recording for you. I will try, though, to try and be online when this is replayed so that I will be around if you have any questions. So what are we talking about today? When you try and look at the internet, you got a problem. Because last I heard, the internet is really, really, really big. And it's very, very hard to coalesce all of those separate parts of the internet and get a grand view. Sure, you can measure the internet in your neck of the network. You could look at it from the perspective of your home, your workplace, your ISP, but that's just one perspective out of literally tens of thousands. How do you get a picture of everything? How do you get the entire internet? Well, interestingly enough, there's one tool that actually brings every last piece of the internet to you. And that, oddly enough, is the job of the routing protocol, BGP. Because if you run BGP, then everyone who is advertising routes all over the net, the job of BGP is to bring all of that to you. And by looking at BGP, oddly enough, you can get a picture of all of the internet all of the time. And this actually gives us, I think, some real insights into what is happening on the internet today, and even some indications as to why it might be happening this way. So let's dive in and have a look at BGP, and in particular, let's look at the last 12 months, BGP in 2023. So the highlights, look, I'll go through V4, V6, some projections on the routing space, the fib, churn and conclusions. So this is 30 years of the internet, all pulled together in one magnificent slide. It actually combines not only my view of BGP in my neck of the woods, one view, but I combine it with another, these days, close to 650 views from both Route Views, University of Oregon, and from RIPE's Routing Information Service, and I pull up all of their views and all of their peers, all of them. And so, in amongst other things, which led to V6, we also introduced a move away from the address plan of the internet up until then. Because up until around 1993, addresses only came in one of three sizes. A bit like Goldilocks and the Three Bears, really, if you're familiar with that one. You had a Class A, which, was just too big. There were very, very few networks out there that really matched the, 16.7 million host addresses that came in a Class A. And then there were Class Cs, to the other end of the address size, which had 256 addresses, host addresses. And although this was kind of okay for small networks for a while, as personal computers started to multiply, as they did, 256 in most sort of enterprise or university environments was just too little. And there was this strange kind of Class B in the middle, which was 64,000 addresses, 65,356 or something, who cares, 2 to the 16th, which was sort of better than a C and not so extravagant as an A. And so it became very popular. But at the same time, we were going to run out of all those Bs very, very quickly in 1992 with, oh my God, disaster. What do? Well, we did, oddly enough, the sensible thing. We got rid of classes. So instead of just those 3 address sizes, we said, well, why don't we just carry the size with the route object? So you could have a /24, a /23, a /22, whatever size you need that we can sort of squeeze into the address space. And this model of routing, and indeed of addressing, classless interdomain routing, kind of saved us. And the life we've been living since then has been all classless. So that was CIDR in 1994. And you can see by the small blip, the growth of the internet stopped for, at least 6 months. But it was back to its steady growth again. Some of you might remember the great internet boom and the subsequent bust around the year 2000, 2001, where, the internet had taken the world by storm. Not really. And although the bust lasted for all of about, 6 months, as you can see there, we were back on again. Because across the noughties, the ISP business changed hands, and it moved from being small entrepreneurs with bunches of dial-ups into the telephone companies actually making a move and swinging the internet into their infrastructure. And all of a sudden, instead of an enthusiast market playing games, this was becoming mass market. Firstly, it was mass market using modems, which was always a pain. Remember them? Horrible. Any of you using them, stop it. We then moved to a permanent connection model using DSL, actually using that analog connection but ganging it up vertically. So instead of having a few kilobits per second, DSL could scale up from low megabits into sort of 10, 20, 30, if you were lucky, I guess, megabits per second with sort of high-speed DSL solutions. And across the noughties, we were deploying like crazy. By 2011, the central pool operated by the IANA ran dry. And we were in the midst of fueling this massive wave of internet. And oddly enough, you hardly even noticed that on the graph. The internet just kept on growing. And even as the registries themselves started to run out of addresses, the routing space just grew and grew and grew, which seems like a contradiction until you realize that what we were doing was slicing and dicing at ever finer levels, so that before you might get a /16, you might have cut that up into a few /18s, which themselves were sliced and diced into 23s and 24s. And it wasn't really until the last couple of years, I think, that you actually see in this graph that pace of growth has finally slackened off some 13 or so years after the first point of exhaustion, those central pools. So let's look at 2023 in particular, and this is the size of the routing table in V4 across those 12 months from every peer of recent route views. So each color thread is one peer. And the first thing you notice, which is kind of weird, is that almost nobody sees the same internet as anybody else. We don't really pay a huge amount of attention to actually all making sure we have the same view of the internet. And in addressing terms, the variations as big as around 18 million addresses between, the peer with the smallest view of default to the one with the most extravagant. Notice that big discontinuity there around late April, early March, where everyone sort of dropped some routes, except the low order, everybody. What was it? It was Turkey, where two ASs, 9121 and 47331, collectively dropped around 7,500 prefixes all of a sudden, really all of a sudden, just in March 2023. And oddly enough, it wasn't that Turkey was pulling out, TT was pulling out of the internet, not at all. But they withdrew more specifics. They were taking out of the network their traffic engineering prefixes and simply working off their aggregates. We'll return to that, I think, because it's kind of an interesting fact that normally BGP carries two roles, connectivity and traffic engineering. And if all of your content is a long, long way away, engineering that traffic to come across all of your available links, so you selectively advertise more specifics down down some of your links, is something we've been doing for years. But Turkey has stopped. TTNet has stopped doing that. And you kind of go, why? And of course, the obvious answer is because all of their traffic is now coming from data centers inside Turkey. And so now there's no real need to perform that fine-grained traffic engineering because all the traffic is now localized, not being imported from America, from Europe, from faraway places. So when we look at dropped prefixes, Turkey wasn't the only ones. There have been a number of networks, and the ones that I think I find interesting is the drop in SprintLink, CenturyLink, both of which are relatively large US providers, and China, and the ones that are growing, Amazon, yes, but the rest aren't really core. The big US networks are not actually growing in the amount of routes that they're advertising on the internet. So in some ways, it's an odd picture that there is some growth, but realistically, there's also some drops. So there's prefixes and there's addresses. And interestingly, if we look at the internet, the V4 internet, from the point of view of address span, how many addresses are actually covered in these advertisements, you get a completely different picture. Because now the great internet boom was a nothing. The consumer model across the noughties certainly was consuming a lot of addresses. We started a little over 1 billion addresses in 2000 or so, and we got to 2.5 billion addresses being advertised by 2012. But by the time we got to 2.5 billion addresses, and don't forget, there are really only 3 billion addresses in play, all of the last, 10 years, in fact 12 years, has been in eking out those remaining addresses, those 500 million addresses or so. And although there's this sort of blip, which was the old /8s given to the Department of Defense, in the year dot, when Methuselah was a young man, the rest of it's actually a different picture. We have been cramming ourselves as the number of devices obviously grew from millions to billions. We did it with almost no additional addresses being advertised into the routing system. And now when we look at 2023 in detail, this is, I'd live to see this. And you start to think about what's happening in the internet. I mean, have we got to the point of the S word, saturation? Has everyone who's ever wanted a connection got one? Is there growth left? Hard to say, but there's more data around that actually suggests that yes, the internet is declining. This is taking a graph of the amount of addresses being allocated out of the regional address registries. And on the whole, across the year, nothing happened. There's not that much to give out. The unadvertised pool of addresses didn't shrink. It grew by about a /8. It's 18 million addresses. And the advertised pool, that's by the way, the Amazon blip, the advertised pool declined by that same amount. The internet, in V4 sense, from addressing, is actually getting smaller. We thought with address trading, moving addresses around, that this would actually flush out unadvertised addresses. They'd be able to make money by selling their unused addresses on the open market, and this would encourage more efficient use. But we've been wrong. In the longer term, and this is that same graph, but now with a midpoint, a start point back in 2018, you see that the unadvertised pool has been inexorably growing. And the only thing that changed that step function was the US Department of Defense bringing some unadvertised addresses up and advertising them. If it wasn't for that, what we are seeing is, in fact, the advertised pool continues to shrink. Sprintlink, wow, 6 million addresses disappeared. Lucent, another big provider, 2 million. AT&T Internet, one of the big three, down by 2 million. Even Google, which didn't have that many addresses advertised to start with, 10.2 million. But by the end of the year, it's down to 9 million. Even Comcast, the biggest retail provider in the US, down by 1.1 million. So oddly enough, the address span is coming down, not from the edges, but right from the core where the largest networks are. The US, those old unused /8s, yes, they all appeared on the network, thank you. And there's Amazon's contribution of 2 million addresses, thank you, Amazon. But there's not really a picture of massive growth. Not really. It's actually one of reduced. The growth of the entire size of the network is slowing down, and from the addressing perspective, it's declining like crazy. Only 1,100 new autonomous systems over the year. Previous year it was 1,400. So in some ways, everything is slowing down or even reversing. And it's a reasonable question to ask, have we reached peak V4? Is this as big as we need to get? Does everyone who need an internet connection have one? Are NATs so much part of the fabric that the growth in devices, and there is some growth in raw device count, is this all just being absorbed by NATs? Is V4, if you will, had its day? Are we now declining? And if so, and that's a fine thing to look at, the numbers are suggesting that, is it all about V6? Now, you look at the 20-year view of V6, and the data doesn't go back beyond 2004. The first look is, oh my God, that's where the growth is. It looks strongly exponential. You see that huge curve between 20 and 22 that, in the early years of COVID, things started to go a little bit crazy out there. And V6 was just hammering. It's slowed down a bit since then. And certainly by January 2024, though, what I do find sort of interesting is that same vertical diversity that we see in V4, not everyone has the same view, is now appearing in V6 as well. And so in 2023 across the year, there is some growth. This is 160,000 entries at the start of the year, and closing the year somewhere between 180 and around 190, 200,000 entries in the V6 routing table. Why there's such a big difference between various BGP speakers out there, not sure. The upper band, I think, is Europe. The lower band is America. Still not sure why. Some step functions. Vietnam decided to, in one of their major service providers, advertise 3,000 new prefixes, and over in Hong Kong, another 2,000, for which we're very grateful. Thank you. But there is one thing, you noticed in V4, the more specifics were coming down. I said that was a declining role of traffic engineering because content is shifting closer to the edge. You don't need traffic engineering. And that's a fine theory, but if you look at V6, the more specifics, which were originally back in 10 years ago, 30% of the routing table, is now hitting a phenomenal 60%, of which, these days, most of those more specifics are /48s. This is insane because there are so many /48s, 2 to the 48th of them, that if everyone did that, your routers would not handle it. They would melt. Why does everyone think that a /48 is the IPv6 equivalent of a /24? I don't know. But nevertheless, everyone advertises a whole hunk of them. 2/3 of the network is wasted in /48s. This is the contrasting view of addresses. So let's just go back a second. Massive growth. Because in addressing terms, what's being actually advertised is not huge growth. Now, it's always hard to find the right unit for V6. And so this isn't /128s, and it's not even /32s, or at least it is, but think of thousands of /32s, So we're rising from, 20,000 /32s being advertised, 20 years ago, up to around 160,000 /32s today. Again, quite some variation. Not everyone has the same reachability as everyone else, and nobody seems to care. As long as you've got your fix from YouTube, Netflix, and all the rest of the video streamers, who cares about talking to anyone else? And so ubiquitous connectivity is no longer an issue for this industry. No one minds, no one cares, no one fixes it. In 2003, the V6 network grew a little, a very small amount. So if you said, well, all the growth in V4 was moved into growth in V6, you'd probably be wrong. It grew by around 17%. It's predominantly /48s. The growth of /32s was very small. The address span just 1.6%. So it's not really growing. So let's now take all those numbers and make some projections from them. And this is again unique. This is the first time that the numbers say we've peaked in V4. Now, I don't know if that's, real, but this is the best fit of those numbers from the last 5 years. Gives you an order 2 polynomial where, in effect, we've reached the top. That it's just a little under a core arrangement of around 1 million odd networks. That's about it. The numbers suggest after that it starts to decline. Whether it's going to happen or not, different thing. But that's what the numbers are saying. V6 used to be exponential. It's now strongly linear. It's a long and steady growth. And, over the coming sort of 5 years, it might well hit 400,000 entries in the routing table, but it's pushing it, That linear growth model is very, very constrained. So it's growth, but not a lot. The underlying network, is more about /48s than anything else. So in absolute terms, because V6 is 4 times bigger than V4 in your routing tables, it's growing faster than V4, but the major issue is BGP will keep on going for some time. It's not under any major stress. The other thing, of course, is it's not the size, but it's the dynamic properties that really, really, really matter. And this is an odd graph. It has the size of the routing table, but now the number of updates I see in my network on the edge. And the first thing you notice is, although the size is growing, the data. If you look at a series of updates that are trying to find the new stable path, and you look at how long it takes for each update event to stabilize, back in 2014 or so, it was around 50 seconds. 2 3/4 MRI timers. These days, it's actually slightly lower at around 45 to getting even closer to 40 seconds. The network is actually performing better, even though it's much, much larger. That, again, is amazing and certainly unpredicted. So it's stable. Routing instability is now concentrated in a small number of pathologically bad cases, and the rest of the network is just stable. But that's V4. No one looks at V6. No one cares about V6. And it's probably evidenced by the fact that V6 is far less stable, far more unstable. If you look at the size of the routing table, this is a log scale, so be careful. As we go up to around 200,000 routes in the routing table, the number of, if you will, instability events, the number of updates, is also kicking around close to that number and has been rising as the routing table rises. And the number of withdrawals has also been growing. So this is not a network that is well contained. It actually has different properties. The growth trajectory has slackened off, and the updates and withdrawals have slackened off largely because of that the last 12 months, but it's still a different profile. The number of unstable prefixes is not constant, it's growing with the size of the routing table. So it's a different network. And for a long time, it was phenomenally unstable because of all these overlays of tunneling V6 over other things. That's really, really hard to keep, if you will, the network stable. And what we're finding now, of course, only recently is that stability appearing with a convergence time that's also around 50 odd seconds or so. So things are getting better, which is just as well. Instability, though, is interesting. If everyone was equally contributing updates, the profile would be along the green line. Every AS would contribute a fixed proportion of updates. What we actually find is, for example, in IPv6, just 2 ASs contributed half of the update load in the last 2 weeks of 2023. So what's actually going on is this instability. It's concentrated in a small number of almost pathologically unstable cases. In terms of futures, there was a period around 98 to 2000 when we thought we're all going to die a heat death of BGP. BGP was growing faster than Moore's law. Costs were rising. Oh my God, it was all disaster. Didn't happen. In general, BGP has been phenomenally well behaved. The drivers for growth are now basically disappearing. And because we're pushing content closer and closer to the edge of the network, and content distribution networks are key to the future of the internet over the coming years, that pushing to the edge has removed all the pressure on the middle. Much of the pressure on BGP is now slackened. We don't even need to use BGP for traffic engineering if all of your traffic is coming from down the road at a data center near you. And so because of that, much of the stress in the routing system has disappeared, and even the growth drivers have disappeared with it. However, there are still folk who get caught out. In Australia, in October last year, one of the major providers, Optus, managed to field routers where as soon as you exceeded 1 million entries, it said max prefix limit, bring the session down, which was kind of a disaster because the session was the session to their offshore network control center. And so the control center no longer controlled the network, it was cut off because, 1 million entries, session shutdown. Optus. So there are probably others being caught in the same trap because that's one of the defaults out there in equipment, that when you get to around 1 million, session shutdown appears to be the default behavior. You maybe should look at that, and if you do exceed max prefixes, you should set your router to freeze the routing table and keep on forwarding packets. Bringing down the session that caused that overload is perhaps the worst possible response. So know your limits in your network. Know how much memory you've got and how much fib capacity, and make sure that you're within safe limits of that. So yes, you're going to need a lot of memory, and it's the most expensive memory you can buy because on those line cards, this is fast memory. So now you're going to need about the same memory footprint for V6 as for V4. So look at that, review them, make sure you know them. And you don't need to carry all the routes all the time. Default is your friend, use it. And some vendors are now bringing out hot caching in their line cards because quite frankly, no one uses all million entries. Once you've gone to Google, Netflix, YouTube, and a few others, that's it. Users don't go anywhere else. And if you had hot caching in your line cards and said, well, you've gone off to Poland or somewhere far away, that might take a bit longer. No one will really notice. And it will be a whole lot easier to keep your router operating within reasonable performance rates with hot caching in your line cards. So those kind of suggestions might help you in terms of looking at the next few years. So I've run through my time. Hopefully I'm within the time limit. Thank you very much for your attention. And with luck, I'm online, able to answer any questions you might have. Thank you.
Okay, so the luck was not there. We were unable to get him hailed in Zoom from Australia. We couldn't get hold of him via phone either, so either we got the time zones wrong or some other problem. So just the interesting bit from that I took out of this when I was in Apricot, because there's another talk from some IP brokers also showing that their IPv4 pricing almost follows that graph of people starting to pull back prefixes from the routing table. So I really do hope that means more and more people are using IPv4 and there's not some other calamity coming. But yeah. Anyhow, up next we've got Jan Vermeulen from the editor from My Broadband, the largest tech news website in South Africa, probably the continent as well. So yeah, over to you.
All right, let's get this party started. So if I make jokes, I think this is something that's actually quite common across cultures on this beautiful continent of ours. So, like, Africans deal with incredible adversity with humor. We see that in South Africa a lot. If my jokes do not resonate with everybody watching, understand it's just my dark journalist humor combined with our typical South Africanness of how we handle things like load shedding and state capture. We laugh in the face of adversity lest we cry. But please don't take joking and lightheartedness for making light of how serious this is. The title is attention grabbing. It is not hyperbole in the slightest. Afrinic is in deep flippin' trouble. Before we get going, some disclaimers. There are people in this room. Is this good? Do I need to stand closer to this thing? Because is this good over here, as long as there's no feedback? There are people in this room that know an awful lot more than I do about specific topics, and hopefully they can add their expertise. But there are also lawyers involved. There's an incredible amount of litigation, and so not everybody can speak their minds. And that's where I have the best job, because I can say things that other people can't necessarily. This is only current as of yesterday. This is an incredibly fast-moving situation, and so what I say here right now could very well change in the next 12 hours. We'll see. And then obligatory, these opinions expressed, blah, 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 batteries not included. And before we kick off completely, so for the folks who are watching online, and especially in Mauritius right now at Afrinic, thank you very, very much for staying the course, for continuing to slog it out in an incredibly demoralizing environment, for continuing to make sure that things tick over and work. Those of us who know what's going on really appreciate you. Please keep doing that. With that out the way, let's see if we can fix this thing. This is one of my favorite lines from The Big Short. Truth is like poetry, and most people fucking hate poetry. That's one of the great things that I get to do with in my job, is I get to seek the truth, I get to look at the truth, and I get to proclaim the truth whenever possible. As to the best of my ability, because the thing is, there's a massive information asymmetry here. And so, in that sense, this is the truth based on the facts at hand. So, because this is being broadcast, and ZANOG and ISPA are recording this, and they probably want to put this on their YouTube channel, I want to propose something. So, whatever I say, fair game. Attributed to me, it's me saying it in my personal capacity as the reporter who has been looking into this for many years. That's fine. But when we have the discussion at the end, I would like to propose the Chatham House rule. So the Chatham House rule is, when a meeting or part thereof is held under the Chatham House rule, participants are free to use the information received, but neither the identity nor the affiliation of the speakers nor that of any other participant may be revealed. Are there any journalists, bloggers, podcasters, YouTubers, Twitch streamers, TikTokers in this room that want to be able to attribute what is discussed afterwards? Or can we hold to the Chatham House rule? So that includes people who are going to be able to participate from the live stream. You don't get a say. The people in the room get a say, unfortunately, and you have to abide by what the people in the room decide. Are there any objections to applying the Chatham House rule to the discussion afterwards? Okay. Unanimous agreement. I'll also just remind everybody afterwards. So how broken is Afrinic? Very broken. And I'll try to do a quick recap. Show of hands, has anybody seen John Curran's update on the current status from ZANOG 2 weeks ago? Okay. So that means I get to do what he's done, which is provide a quick update, but I get to do it in much less flowery language. Love John Curran. He is a case study in how to speak the truth and how to give an update when you're under constant threat of being sued. If you want an object lesson on how to handle a difficult situation like that, he's very careful with his language, very careful with his wording. You have to infer a lot and connect a lot of dots. I have the benefit of not having to do that. So let's call a spade a shovel. So where this starts for me is around 2019, a Californian internet investigator named Ron Gilmet contacts me and says, hey, listen, I think I've uncovered something pretty freaking shady at Afrinic. And I'm not going to take you through the whole blow by blow. Bottom line is, we ultimately catch Afrinic's number 2 employee, Ernest Bayuranga, stealing IPv4 addresses from the free pool and leasing them as an IP broker. Then there's a whole separate part of this that involves other individuals where they hijacked a bunch of legacy IP address blocks belonging to South African institutions. That includes government agencies, companies, what eventually became SITA, and using those, leasing those out, essentially. And so, for those who don't know, legacy IP address space is IP address space that you don't have to pay Afrinic a membership fee for. So it's incredibly valuable in that sense. Yeah, so that's where this starts. So rather than focus on dealing with that and reclaiming the stolen address blocks, I think the address blocks stolen by Ernest was relatively easy because we had compiled like a whole dossier on what had happened, and Afrinic was able to augment that data with their own internal data. No problem, reclaim that address space. It was put in like a hold, but everything suggests Ernest was not alone, right? So you have to find out what else had been stolen and reclaim that. And then the legacy address space stuff is incredibly hairy to deal with because there's people in that space using it right now who don't know that they've bought stolen space. And you have to reclaim it from people who are not, Ernest was like, you've caught me. Police charges were laid against him. He was fired, and the address space was reclaimed. The legacy IP address space involves people not on the African, one guy who's not on the African continent and one foreign national who, as far as we know, is actually resident in South Africa. But untangling that is much harder because those guys might sue you, and one of them, in fact, has instituted legal action against Afrinic, which he ultimately lost. But that alone would have been a task on its own. And rather than focus on that, what Afrinic did is they went after a resource member called Cloud Innovation. So they decide that they're going to bite off another big chunk that they obviously couldn't chew, and Cloud Innovation rallies its allies and associates, and it ultimately brings Afrinic to its knees. Now, lest it be said that I'm casting Cloud Innovation as the bad guy, put yourself in Cloud Innovation's shoes. Before I tell you anything else about Cloud Innovation, you own IP addresses, the ISPs in the room, everybody else in the room who's a resource member at Afrinic, and they threaten to take your resources away for whatever reason, all of it, by the way, not just reclaim what you're not using, they take it all back. What would you do? Right, so with that in mind, let's explore a little bit what's happened here. And hopefully you'll come to realize, as I have, that there are very few bad guys in this story. Like, there's just people. There's people doing bad things, there's people doing good things. But it's just people looking out for their own self-interest. Why go after Cloud Innovation? I think that table, for anybody who knows IPs, explains a lot. Cloud innovation is sitting on a ton of space, 2/12s, 2/11s, and I worked out the street value based on $50 per IP. That's 314 million US. For those who want to work in Rand, multiply by, where are we today? 18.8, multiply by 19. You're talking billions of rands of asset, right? That's also incentive for why cloud innovation fought tooth and nail to protect it. It's a huge thing that it's sitting on. And what Jeff was speaking about earlier today was actually quite encouraging. As we start talking about what's happening in IPv4 and IPv6, you know, the natural progression of what's happening there might actually feed into a solution of what happens here at the end of the day. Okay, so cloud innovation sits on a ton of resources. Now, it's more than a rumor how cloud innovation got these resources. The founder of cloud innovation and Laris, his name is Liu Heng. He and I have spoken at length multiple times. I've actually put the question to him because it's basically an open secret in the industry that cloud innovation applied for these addresses and the reasons it gave, because when you apply for IPs from Afrinic, you have to give reasons. The reasons he gave was he's essentially going to use these to provide VPN services to people in mainland China so that they can punch through the Great Firewall. For those of us in Africa, that's a very noble cause. On China mainland, not so much. But that means that whoever approved these resources knew that these resources were not going to be used in Africa. They were going to be used overseas for a good cause. Now, what happens, there's a huge amount of consternation over this huge chunk of address space that just gets assigned to a guy who's launched the company technically in the Afrinic region. It's in the Seychelles. And who, by all accounts, like he's quite open about it. He's not African. He's a Chinese national. And so this causes huge friction in the community. And we'll talk a little bit about like those geographic and cultural frictions that exist in the community, because I think it's important to understand those while we discuss solutions. Okay, so what happens is cloud innovation, I'm going to now try to speed run this because we have to get to the discussion at the end. That's the meat and potatoes. So cloud innovation gets its first /12 in 2013, the rest of its resources in 2014. Within a few years, though, cloud innovation is leasing these addresses. And it's unclear where the VPN service went. But it's not doing it directly. So there's a new company launched called Laris Cloud Services Limited, sometime in 2016 or 2017, and there's an arm's length relationship between cloud innovation and Laris. They refer to one another as partners, but Liu Heng founded both. It's the same thing when you cut through it all. So what I do know in terms of the timeline, 2016 versus 2017, is the Laris org record, org LCSL1 Afrinic, was created on 19 January 2017. So if you want a timeline, it's roughly then. Then in 2020, Afrinic sends out essentially what's a cease and desist, or a warning to go, we are going to take back your resources unless you can explain to us how you're using it. Very abridged. But essentially, Afrinic alleged three things. Cloud Innovation's whois records do not match how the IPs are used. Cloud Innovation is no longer using its IP address blocks for the reasons it gave when it applied for them. And most of the address space was being used outside the Afrinic region. Now, Cloud Innovation, for its part, disputed keeping disputed the whois record allegation. It says it keeps its whois records more up to date than most. I could not find much fault with that statement. If I compare how Laris and Cloud Innovation handles its whois affairs versus the average South African ISP. It also disputed the fact that it was no longer using its address space for the reasons it gave when it applied for them, like disputed it outright. And then also said that there was, by the way, there's no mechanism to tell Afrinic that I'm using it for a different purpose now. Right, and then the third one, it said that there was no Afrinic policy blocking the address space from being used outside the Afrinic region. And that's true until now, until we reach soft landing. So Afrinic is now in its last /8. There's a new policy for that specifically, which says that there's like a whole complicated thing about like you can use it out there, but it has to like link back to Africa, blah, 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 blah. But until the last /8, you could use your resources however you liked. And so there's really only one leg that I can see for Afrinic to stand on. And that's in the Resource Services Agreement that everybody has to sign, the RSA. There is a line in there that says that you have to use the resources for the reasons stipulated. Now, as I said, I've had very long conversations with Liu Heng in the past, and he has refused to confirm or deny whether indeed he got these addresses with the motivation that they would be used for VPN services. There's no documentary evidence about what he applied for these addresses for, but there are witnesses in this room who will sign affidavits attesting to the fact that Liu Heng indeed applied for these resources to launch VPN services. For whatever that's worth, it might be a moot point in the courts at the end of the day. So what I'm trying to say is that Afrinic potentially had a leg to stand on, but there's also plenty of resource members in this room who will go, yeah, but if they go for cloud innovation, even though that is a lot of space, they could come for me next, even though I've got a much smaller amount of space. If you apply the law of universality and you say what's good for the goose is good for the gander, that's a potential problem because Afrinic could come for your resources next. And so that creates a kind of a band of people with vested interests, even though they might be diametrically opposed in ideology. So Cloud Innovation responds to Afrinic's threat with a disparaging letter, essentially accusing them of not knowing what the hell they're doing, and followed it up with an application for an injunction in the Mauritian courts on 13 July 2020. Now, I want to illustrate something a little bit about how the Mauritian courts work. After hearing the case, the court only set the application aside almost a year later, 7 July. It took a year to hear an injunction in the Mauritian courts. Okay. And we'll get to some more stuff later on. And then as luck would have it, luck, maybe more than luck, but let's not assume anything. As luck would have it, the Afrinic board was sitting that very week, over the 7th and the 8th of July, for a board meeting. And it adjourned, just for like a little bit of detail. They started the meeting at 9 on the 7th of July. It ran until after 1, and then there were complaints that this meeting was running far too long. So they adjourned until the next day. It was on the 7th that the court hands down the judgment in the interdict application. It dismisses the interdict. So Cloud Innovation loses. The very next day, the Afrinic board resolves, we are taking away Cloud Innovation's resources. They issue a public statement to that effect, and faced with the prospect of seeing his multi-million-dollar business go up in smoke, Liu Heng, Cloud Innovation, launches an all-out assault on Afrinic. What does an all-out assault on Afrinic look like? Jan, once again, are you speaking in hyperbole here? Afrinic has a list of court cases on its website. I apologize if I give anybody motion sickness. If you get any motion sickness, wave your hands. A microphone, sorry. Yes, people are trying to listen in. So this thing will loop forever, so that you guys can see what I'm talking about when I'm talking about lawfare. Where does it stop? 59. And there's more. There are cases that are not listed on this. And if you go through that, then so the first thing that happens in the opening salvo between Cloud Innovation and Afrinic, Cloud Innovation is able to get a court order in Mauritius that locks Afrinic out of its bank account. It locked Afrinic out of its bank account for 2.5 months. It did this with a damages claim. So first it files a damages claim. It says Afrinic owes me 50 million in damages for what it's about to do, or for what it's doing to me. Right? Then it files a garnish for an application for a garnish order. The garnish order does not hear the merits of the case. It is granted under what they term at own risk and perils, which means that the enforcing party, in this case Cloud Innovation, can serve the garnish order on Afrinix Bank, and if there's any, if it's found that it's done so improperly or whatever the case might be, then Afrinic, maybe the bank, can sue Cloud Innovation in return, because it's essentially the court is saying, we're not saying you can do this, but we've got a mechanism for you to attach the assets to make sure Afrinic doesn't rabbit with it, which was incredibly low risk, but be that as it may. That's why this mechanism exists. But like, if there's anything wrong with what you've told us, if there's anything wrong with the way this application was handled, if there's anything wrong with how you implemented this garnish order, you're on the hook for it. But Cloud Innovation is a company registered in the Seychelles. Like, its liability in Mauritius is incredibly limited. And so there is no risk and perils. It can essentially do this at will, because the chance of facing consequences for doing so improperly is incredibly low. But this comes back to later when we need to discuss what approach, if we're going to fix this, how do we make sure this doesn't happen again? All right, so Afrinic's drowned in legislation, and this lawfare is like a thing of technicalities. How does Afrinic get its bank account back? It launches a counter application to say that the power of attorney that Cloud Innovation signed for its lawyer in Mauritius was wrong. The court says, yeah, that's right, and it voids the garnish order. 2.5 months later, but at least that's shorter than a year. Right? And like this whole thing, it's like a battle of these technicalities between the parties. So if you scroll through this, you'll see that there's a lot of things that look positive. It says application withdrew, we won, application set aside. It looks like Afrinic is winning. Afrinic is not winning, not in the slightest, because where it matters, it's lost. So where Afrinic stands today, it is headless, it is rudderless. There's no one in the organization who's empowered to make strategic decisions. So the staff who are working there, that's why I thank them for what they're doing, because they're doing so under incredibly difficult circumstances. Essentially what happened was, as this grew to a crescendo, is Afrinic was about to hold elections, because how Afrinic works is it's a members-based, supposed to be a members-driven organization. So the directorship is, unlike corporates that you might be familiar with, they are elected. Sort of like a board of trustees at a sectional title here in South Africa. So the trustees are separated by geographic region. There are some who exist without region, and then the membership vote on who they want to see as their candidate. And they were about to have this vote, and this got so ugly. And I think it's important to understand the quagmire that is Afrinic elections if we're going to talk about long-term solutions for this, right? So this most recent election, there were incredibly serious, let's just use the word serious, allegations about what Lu Heng was doing behind the scenes. So there's several parties allege that Cloud Innovation, but not directly, so not Lu Heng directly, but a sister organization of a sister organization was essentially buying people's votes. There are several people who will testify to this, by the way, but essentially the allegation was that the organization that was representing Lu Heng's interest and Cloud Innovation's interest wanted people to sign over their MyAfriNIC portal login details so that they could cast the vote. The reason for that, by the way, is because there were allegations that there were previously attempts at vote buying, and that these guys wanted them to vote along. And so this time around, it's like, no, you have to give us your MyAfriNIC login details, we'll cast the vote, and in exchange for money. Now, Liu Heng has denied this vehemently. Liu Heng has said the accusation that he is trying to buy votes is stupid because it's unaffordable. Like, it is too much money. But the evidence to the contrary, I must say, is overwhelming. There are just so many people who have said independently, people who are not active members, who are not on mailing lists, who do not deal with Afrinic every day, who are like, what is this email I got that's offering me money to vote according to a certain line? And so, what exactly has happened there, unfortunately, we don't know yet. But the counter to this, by the way, is that there is a group inside Afrinic that pretty much, they don't buy votes, but they cook the elections, is the allegation. And so there are these two camps that have, there's actually way more than two camps in Afrinic. There's probably like 4, 5, 6 camps. But these warring camps that kind of made it unpalatable for everybody else to be there, were essentially, the one was manipulating Afrinic policy and sometimes just violating policy, allegedly, to ensure that certain candidates were not even on the ballot. And on the other side, you have people who are going, well, we need to win this thing at all costs, and allegedly bought votes. And so the elections get ugly. The Cloud Innovation launches another injunction application against Afrinic because of the fact that none of Cloud Innovation's preferred candidates were even allowed on the ballot. And the court ruled in Cloud Innovation's favor, said Afrinic violated its policies. And so the election couldn't happen. And then board members' tenures started running out. And so one board member can't continue, next board member can't continue, and now the board is incorate. And crucially, before I make everybody seasick, let's just stop the slide there for a second. Crucially, and this has been, by the way, there are plenty of people in the room who tried to warn Afrinic that this was coming. That if you don't get credit today, we don't have time to go through it all, and I don't want to miss anybody out who has also silently contributed. There have been a few vocal people, but there are also people who've worked behind the scenes, warning diligently. Afrinic's policies are not well thought out. They need to be revised. You're going to run into trouble. The hiring of the former CEO, Eddie Kaihura, who, by the way, is a great guy, was similarly mired in controversy because there was an allegation, for example, in the Afrinic bylaws, it says that the CEO cannot be from the same country in which Afrinic is registered, right? Mauritius in this case. So in other words, no Mauritian is allowed to be an Afrinic CEO. That is in direct conflict with Mauritius's own laws on equity, on hiring equity in the country. And so if you wanted to attack, that's another avenue on which you can attack Afrinic. Right? So Afrinic was doing such a bad job of guarding its flanks that it just it had these gaping holes in its policies that allowed Cloud Innovation to just drive straight through them. Essentially do whatever it needed to do to ensure that Afrinic couldn't essentially torpedo its whole business. And so the situation with the elections we've covered. Then the two-punch of the 1-2 punch is that another application comes and says the board cannot make decisions as the board while they are incorate. Afrinic needs an election, and the board needs to be reconstituted, become corate, and the organization must continue within the guidelines of its own policies. So there's another failure of Afrinic policy. Why in the hell is there no way to reboot the thing? if your number of directors falls under quorum, if you just go look through basic things like the Sectional Title Act in South Africa, there's always a way to recover. How is there no self-recovery mechanism built in? And once again, Afrinic was warned about this repeatedly. And, but there was no one with the incentive to ever test the policies. And so people just ran roughshod over these policies, carried on as if nothing was wrong, until the one day you try to take someone's $300 million asset away, and all of a sudden he has all the incentive in the world to rip the holes in your policies to shreds. And so before you want to tackle something like this, so fair game. If Afrinic wants to test in court and through its policies where the cloud innovations allocations were done improperly, that's fair. That's fair to do. But your house needs to be in order before you do that, because otherwise this happens. All right, so that was the final paralyzing blow to Afrinic. And so there's now no board, no CEO. The CEO's contract ran out. And so there's two potential narratives here. The one is that there was an avenue to extend Eddie Kaihura's contract, and they didn't take it. And the other one was that, no, there's after that application to say the board can't do anything, the board can't appoint a new CEO or extend the current CEO's contract. So, there were varying legal opinions on this, and ultimately the legal opinion that said Eddie has to leave and leave Afrinic without a CEO, that legal opinion won out. And off goes Eddie, which was the last backstop. Because there's certain things in Afrinic's bylaws that allows the CEO to do things while the board is being reconstituted. And now there's no one with that executive power. Okay, so based in receivership, that happened on the 12th of September 2023. Receivership is not a bankruptcy proceeding, right? So people might associate that with business rescue or liquidation. This was essentially an administrator that was appointed with the exclusive purpose of reconstituting the board and making sure that there's an election and that the board is reconstituted based on the elections in line with Afrinic's policies as written. But the receiver was to hold the elections within 6 months. That would have been yesterday. And we might have had a very different conversation here today. But a former Afrinic board member and a guy who managed to convince the Mauritian courts that he can act as the chair, we haven't quite figured out how that's happened. His name's Benjamin Eshun. He wrangled a stay. So without boring you with the technicalities, you can watch John Curran's brilliant update on how we got here. But it was, once again, Mauritian court. It was an injunction with a counter-injunction and a counter-counter injunction, status quo. And as far as I know right now, the receiver is stayed permanently until something else happens. So Afrinic is back stuck in limbo, and a former board member at Afrinic orchestrated it for it to be that way. And that raises serious questions about what the game is here. Because despite their differences, right, despite the differences between resource members who are aggrieved with the amount of resources cloud innovation was given, who might not like Lu Heng, whatever the case might be, there was a broad agreement amongst resource members with say, with a huge amount of say in Afrinic. One might even say the majority of the vote, who said that the receiver was a very good thing. A very good thing. And in one fell swoop, that's been undone. Well, I say one fell swoop. It happened over months in the Mauritian courts. Something that the majority agreed was good is now blocked. And so Benjamin Eshun, also during this, he asked the Supreme Court to appoint 3 directors to call an AGMM. So Benjamin's alternative to having the receiver do the election is he wants the court to appoint 3 directors. I don't know on what basis he wanted that done, because Mauritian court documents are sealed. Unlike in South Africa, where they are public, In Mauritius, they are sealed unless the people involved open them up, and you can only publicly disclose them under certain circumstances. And the only parties to this was Benjamin and Afrinek. So previously, the court documents could leak out to the press, to the rest of the membership, and so on, because there were lots of people involved. And Cloud Innovation has lots of allies and likes to brag about what it's done. And so the court documents became public and readily available as a result of that. Now, we have no insight in how the Mauritian courts came to this conclusion, what Benjamin was asking for, but mercifully in this case, the courts actually said that ruled against Benjamin's proposal. So against the proposal to appoint 3 directors, call it an election that way. So, but I know previously Eddie Kaihura, the former CEO, he had attempted something very similar, but he had gone with essentially an independently drawn up list of candidates, senior people that he did not necessarily see eye to eye with, and proposed that to the court as a way to get out of this. So this is now before the receiver application. So because the receiver thing is quite lengthy, you have to now wait for 6 months to call an election. So Eddie was trying to pull Afrinek out of its stall quickly and go, hey, here's a way for us to reconstitute our board and get, jumpstart this engine. And the court struck that down too, didn't like it. Then John Curran explained that Eshun is believed to be seeking leave to appeal in the Judicial Committee of the Privy Council of the UK. Because what happens when you reach a stalemate in Mauritius is you have to appeal to the UK. That's now the next step in this process of that avenue of attack. But don't worry, that's not the only option and not the only way out of this Gordian knot. Curran also warned that Eshun's case could take up to another 2 years to resolve that way. That's the current status. I asked Benjamin for comment. This is what he told me. I'm just going to read it into, I'm walking away from the microphone the whole time. I'm very sorry to the people who are watching online. Dear Jan, I regret to inform you that the matters in question are currently sub judice, and therefore I am unable to engage in any discussion or provide comments at this time. Thank you for your understanding and cooperation in this matter. Regards, Benjamin. So that's that. No detail on why he did what he did, what he's hoping for, and whether indeed he wants to go to the Privy Council. So now for the meat and potatoes. And let me offer some options and some thoughts to hopefully kickstart a discussion about how this might proceed. If I can forgive a jab. So dividing internet resources by geography, in my not so humble opinion, is incredibly dumb. But we're stuck with it. So there comes a stage where you have to put aside your idealism, realize the world you're living in, and pragmatically look and go, okay, this is how things are for now. We can strive towards change, but we have to exist in the system now. What do we do? And so John Curran explained that the NRO, so there's like 3 different organizations that handle various aspects of number resources on the internet. The NRO is one of them. NRO is like is a gathering of the registries, right? Now, the NRO has asked one of its sister organizations, the ASOAC, which is an ICANN organization. So those are the big guns, which is why ICANN's logo is on the screen. So ICANN is being appealed to here to create to flesh out the policy that governs RIRs, regional internet registries like Afrinek. And essentially, it's saying they've asked the AOCAC in particular, and this is now John Curran saying something without saying something. They've asked the AOCAC to look at a policy to de-recognize RIRs. And so that to me is a shot across the bow. It's if Afrinic continues to fuck about, that's my one PG-13 fuck for the day. Then the ultimate consequences could be that you de-recognize Afrinic, you start up a new organization from scratch with policies properly thought out, with everything in place, with essentially a constitution underpinning the organization that, so that policies can't be messed with at will, and you start from scratch. But that is not an easy path either. For anybody who was involved in the .Africa situation, when, like, invariably what's going to happen is there are going to be vested interests that are, would be opposed to ICANN doing that. It will be taken to court and it'll have to be fought out there over several years. But that's a path forward. And so even though it'll most certainly involve legal action, at the end of the day, Afrinic 1.0 will cease to exist and Afrinic 2.0 will be put in its place. By the way, ASOAC, that stands for the Address Supporting Organization Address Council. I don't know why they have address twice, but be that as it may, it's one of those acronyms. Now, on the topic of pragmatism, there's also people who are like, listen, just consign Afrinic to the abyss. We don't need another RIR. That's tempting, but not realistic. In a system where other RIRs exist, Africans have to have sovereignty over their number resources. It is essential. We can discuss that. This is me throwing thoughts out there for us to discuss. I'm happy to back it up later. So, in our discussion, I want to just also throw this thing out there, which has really stayed with me since I've heard Mandela speak the words himself. Your duty is to work with human beings as human beings, not because you think they are angels, right? So, like, understand where people are coming from, understand the reality of the situation. So, let's think about corruption. Can it be eliminated? Is it worth expending the resources to eliminate corruption at its root? Or must we accept some level of graft so long as things work? And let me give two examples. There's a functional difference versus someone scoring a sweet international trip versus someone scoring a /8, right? So that is something to think about. Sometimes pragmatism is more effective than enforcing a moral code. So instead of trying to catch corruption and weed it out and punish people for example, accepting bribes to fast-track your driver's license, build it into the business model. That's one option. Then the other thing, I was almost in two minds to bring this up, but Afrinic is deeply divided, and so is Afrinic, and there is incredible bigotry. Sorry, this was, excuse the spacing issue, this was built in a different package than it's being displayed with. So this is just a basic overview of Anglophone and Francophone Africa with some of the other languages that make up our beautiful continent as well. And the reason I bring this up, as uncomfortable as it is because from the beginning, there was a deep divide in Afrinic along these lines, Francophone and Anglophone. And even though the cultures in those countries differ significantly and people clash, like what ends up happening is a form of tribalism. And so I am, in the spirit of saying the uncomfortable truths out loud, I'm throwing this out there in the spirit of understanding the deeper problem so that we can build a sustainable solution. So there's, and the reason I was hesitant to even go here is there's electioneering happening around the world, and politicians love stoking our base tribalist instincts for their own gain. Propaganda is more effective when you have an enemy. But while we face the ugly truth, we might as well face the totality of it. And, you know, perhaps as I was thinking about this, I'm like, maybe at this rate, we shouldn't just have one RIR for Africa, if that's the way it's going to go. But also, I'm reminded, those lines are imaginary. The only meaning they have is the ones we give them. Inter-RIR transfers, competition can be good. Other RIRs are doing this. Lots of members are asking for inter-RIR transfers. That's where you move your number resources, your IPs, your AS, your whatever, to RIPE or ARIN or APNIC or wherever you want to go, where you find things are more palatable for you. But in a world of inter-RIR transfers, how do we make sure AFRINIC remains an attractive option? Because the thing is, for a lot of the vested interests, they don't care if AFRINIC's an attractive option. They just want security for their number resources. But the people who are going to solve this problem have to think through that. Then we have to seriously consider leaving Mauritius, which is another unpopular thing to say, as AFRINIC. We have to evaluate alternatives very carefully, though. You have to look at the stability of the country that you're going to put it in. You have to weigh the robustness and the independence of the judiciary. You cannot have a situation where a garnish order is granted to an offshore company at own risk and perils. That's bad. You can't have a situation where the ultimate decider, like if things deadlock, you appeal to the UK government. That's a problem. So these are things that need to be thought about when we think about permanent solutions. Then, should litigation continue against Cloud Innovation and resource members like them? Should those resources be reclaimed? And so elsewhere in the world, things are a little, I want to say things seem a little more forgiving in that sense. It's only if your organization collapses that the number resources get reclaimed. Reclaiming number resources from someone who is still doing business, it's sort of thing. Is there a system to fix that? All right. I'm going to remind you of the Chatham House rule, and then I'm going to open the floor to questions, discussions, and comments.
We are running quite late. We extended the session a bit, so I think we can't have long discussion sessions. Lunch is already on the go, but I guess that there is an urgent need for some people to have a chat, so let's try and keep them brief.
I'm not going to go
let's
into
keep
lunch.
it on topic.
I'm not going to go into lunch. The part
and
of the
let's
reason
keep it friendly.
Sorry. Part of the reason we chose the slot is so we can go into lunch. I'm not going to go anywhere. I'm not going to go have lunch. I'll be right here. Yeah. So let's do this thing.
Hello, my name is Mark Elkins. Why am I here? I used to be a board member. I was a board member of AFRINIC for 6 years. But I've also followed AFRINIC since before its inception. I do think when you start with stolen versus cloud innovation, stolen as in employee number 2 stealing stuff, I think you're losing, you're showing perhaps the flavor of the company, the organization, but I don't think that's cognizance of why we're here today, which is how to unfuck it. Why have I got, who is information out of date? I have no idea. Oh yeah, Lu Heng's information was out of date, and as far as I understand, when he was told to update it, he told them to F off.
That was there. The official line from them was, oh, they went and checked and there were a handful of records that were, but yes, point taken, but we can debate
so
the relevance.
He refused to update the information. That I agree with. I think at the end of the day, yes, he probably did use it for VPN usage. And then if remembering that he's from Hong Kong, and initially Hong Kong wasn't, you could do things there, it was under sort of pseudo-British rule or stuff like that. And I think his biggest fear of admitting anything is that if he does admit that he uses it or used it for VPN purposes, he would probably get locked up and then murdered or something, I don't know, whatever. So obviously he's against his being killed or put into prison. I was chair of non-com at AFRINIC for a long time on multiple sessions, unless I was actually trying to vote or something. And I can say that the voting systems that were involved on membership being, or people being voted onto the board, I believe it was free and fair, apart from influences on people who had the opportunity to vote. I believe the systems that actually ran were correct. I didn't see any errors in it. There would be 3 people, whoever was chair of NOMCOM, the CEO, and the law guy? Ashok. Were the 3 people that would unlock the system.
Yeah.
But I do believe it was fair.
Okay, so let's pause there for a second because there's something I forgot to mention, which is that there was an incident where, and the policy still stands today. So previously there were no major impediments to who can be appointed or who can stand for election. And at some point, those requirements were changed to you had to have attended a certain number of, and that, there were, so there's policy changes, sorry, let me finish that thought. Yeah, sorry, full sentences, sorry. There was a policy change implemented where suddenly you had to have attended 3 meetings. I'm sorry, I'm rushing because I'm cognizant of how much time. So all of a sudden, there's minimum requirements on who can stand for the election that weren't there before. And the problem isn't that. Implementing requirements is not a problem. The problem is that they can be implemented on the fly and by the board without the members having any say on that. And so when I'm talking about problems with the elections that need to be fixed and why I believe a constitution is important, it's so that board members can't do that.
Well, then I really am in the shit because I helped put that particular thing in place because we wanted people who are interested in the organization rather than any Tom, Dick, and Harry deciding that he was going to do a power play. Technically, in the bylaws, and I checked it because I got it on my laptop, 13.8, auto reappointment of board members if there's no person that can actually take up no new person that can take the seat, then technically the previous board member is simply reappointed, and that simply hasn't happened for some wonderful reason. So there's something else going on in that organization. 22.2 states that funds, if Afrinic does fold, the existing funds after any settlement need to be moved to a similar organization, i.e. Afrinic 2.0, hopefully.
That was very forward-thinking.
We tried. And then the problem with Afrinic is the pricing is high. Always has been. But then I think that's also the case of any organization that gets created, the CEO, etc., will try and extend the scope of that organization as much as possible so he can make as much money as possible. I use the word he, she, it doesn't matter.
Yes.
Those are the points that I came across. I am all in favor of Lu Heng. Please just keep that V4. We don't give a shit. Because we're going to move to IPv6. We've got to move to IPv6 one day, and the sooner it happens, the better. And I'll sit down now.
Thanks.
Great discussions.
Thank you. Thank you, Mark. I'm going to go,
I'll be quick.
To you, Alan, and then to the, but you were first.
Thank you. I actually asked my question out of line. I'm so sorry. You made a couple of statements. First of all, thank you very much for the synopsis. I was a founding director of Afrinic. In those days, everything was going great. We were still doing just technical coordination. It really became a political organization that nobody wanted to be a part of. Vika Mpasani ended up being the representative from South Africa on the board of directors. And from then on, it was kind of questionable. And I still question all these things that you think could possibly be fixed up in a version 2. I'd just like to point out there is another option, and that is that there is no registry for Africa, and that Africans can go to Europe or Asia or America, and you didn't offer that as one other potential option. You just said how difficult it is to actually unfuck the current situation.
So that is an option, and my stance was that I think Africa should have sovereignty over its resources. Now, that is not a universal view, but it is a political football. So yeah, we could go back to the old system where this part of Africa gets its resources from ARAN, and this part of Africa goes to APNIC, and this part of Africa goes to RIPE. to get their resources. But that is unpalatable for a number of reasons. And ideally, it shouldn't be regional at all, right? That's why I said I think it's dumb that it's geographic at all. But let's get real about the politics of this situation. It smacks of colonialism, right? Let me just call a spade, and that's why it's unpalatable for people.
Hello, my name is Frank. I'm visiting from Tanzania, and I wanted to ask for a clarification of something that if I got it right, what you said. When the applications for the allocations were made by Cloud Innovation for VMs, as we all believe, you said Afrinic staff knew they were used outside Africa.
Yes.
But the VMs could be in Africa, potentially, as far as I know.
Yeah, absolutely. But the ultimate customer is in China. So
accessing a VM that is in Africa with an African IP.
Potentially an African IP, but it didn't have to be. It could those VPNs could terminate anyway. So he could, and it might be if you're trying to break out of the Great Firewall and you're offering a VPN service, it might be a great idea to have servers all over the world. And so, but yeah, the thing is, based on the very credible testimony that I've heard, the fact is that whoever assigned these resources to Cloud Innovation knew from the beginning the end customer was people in mainland China. It was not Africans. Yeah, so that's the distinction I wanted to make. Thanks.
Hi, Sander Stefan. First want to mention I'm not an Afrinic member. I'm from the Netherlands, so don't want any colonialism. I'm very much against that.
Dude, my surname is Vermeulen. Guess where I'm from?
I know, but happy to help if requested. Will not give unsolicited advice here. But the important thing is I'm currently a member of the ASO-AC that you mentioned.
Cool.
So while I can't speak on behalf of the organization, I'm not the chair. I don't have any power on my own. So for all the official stuff, please go to the website. I do want to say that we are taking the input of Africa very seriously in the whole ICP2 processes we are doing. So the first question we got was to review a document written by the Executive Council, by all the CEOs. For that was a task we had to do, so we did that on our own. But then the follow-up task is to actually come with updates to ICP2. We are working on that. We're first establishing like the principles, what are the things we want, without going into all the details of getting the right wording. And after that, we will go to finally write the text. We will do rounds in all regions, so we will ask the RIR staffs, including Afrinic, to do surveys or what they need to get input from this region. We are also going to attend the RIR meetings, which Africa doesn't have at the moment. So we are looking at options to do things there online, so it's accessible for everybody. And so we are trying to keep the African people
not involved in the fight in Mauritius right now. Get involved with the people who are trying to get Afrinic back on its feet, to get an election going, to get board members in place. If your organization is not involved in that yet, please chat to the people who are involved in that fight. And the more people can get involved to get that done and figure out what's happening with the stay of the receiver and all that stuff, the better.
Hi, Jan. Paul, I think it is right to disclose that I am Crystal Webb, one of the parties who has an injunction. In general, thank you for giving other people a really good synopsis. One area where I think there are two areas where I fundamentally disagree with you. One, I think you take far too charitable a view of John Curran. I think there's quite a lot of problems there. But the second thing is that, yes, there are things on which we should critique the Mauritian legal system. There are some really daft things with Mauritian courts, one of which is the way its sub-judice jurisprudence is developed. It does pose problems, and I say that from the perspective that I can't tell you about certain things that are in court papers because Afrinic refuses consent for the matter to be discussed. So, take it from there. On the whole, though, the Mauritian legal system is manifestly well developed. And, you know, if you look at the guys running .Africa and so on, I don't know, with ZARC rebranding, I'm not sure what they're called when they're in Mauritius, but they put their fundamental operations in Mauritius. People choose to be in Mauritius as opposed to other jurisdictions for very good reasons, which include the functioning of their courts. In this particular litigation, yes, some of the weaknesses in Mauritian jurisprudence really come to the center, and some of the problems within the way their courts operate come to the fore. But as a litigant in the matter, I can assure you that 99% of the reason why the litigation is dragging as much is because of the malevolence of people at Afrinic trying to drag the litigation across. And without going into the particulars of an application because of sub judice, what I can state without any fear, because we've got the dismissals of, is that one of the reasons why anybody who goes to court now and asks the court to appoint directors, which is provided for in the Companies Act, that application has to be dismissed by the court. And the reason it has to be dismissed is because Afrinic has opposed the first application to appoint directors so that the board is never incorate. And it has no rational reason for doing so, other than that it was quite happy to drag into litigation. And that leads me to, you know, so thank you for the note. But I think one of the most powerful ways of ensuring that Afrinic does actually get from its fucked state into a less fucked state, because this isn't, you can't fix this sort of thing overnight. But one of two things has to happen. Either the legal representatives of Afrinic, or more importantly, the internal legal officer, needs to actually go to the court and say, listen, court, I have no faculty to operate on behalf of the company. As an officer of the court, I have to tell you this company is headless. Please appoint a curator ad litem. Please do something. You know, you express disbelief about how did Benjamin Eshon convince the courts that he's the chairman of the board when the court has already ruled. Well, no, because the papers come with an Afrinic seal that is provided by the Afrinic legal director. So as long as Christian Dondi is prepared to go along with Benjamin Eshon, this matter is going to be litigated, because how does the court deal with it? So quite honestly, and I've expressed as much to him, but as far as I'm concerned, he has an ethical obligation as an officer of the court to inform the court of the frailty of the situation and ask the court to appoint a Mauritian barrister as a curator ad litem. It's, you know, not usual in corporate matters, but there is precedent for it. And, you know, again, I probably have to disclose I've consulted on this quite extensively. Or they could just withdraw their resistance to the appointment of directors pursuant to the original application. Now, of course, that's really good for my company. So I am, you know, saying, stop opposing my fucking application, and you'll get a board elected. Probably not the board that my company or associates want to elect, but that's irrelevant. So I don't think it's fair to at this juncture say that lawfare, because again, if you look at the list, there's a good 30-40 cases that Afrinic has experienced with Net Dynamics, whatever the guys and Elad Cohen and all that. Afrinic has won a lot of cases against parties which legitimately ought to have taken across. But there is this insufferable arrogance that comes from the way Afrinic chooses to litigate. And whatever you may think of me or my company or Lu Heng or any of his companies or anybody else, we have to decide whether or not we believe in the rule of law. And if we believe in the rule of law, then we have to accept that there's going to be shenanigans. But legal shenanigans are easily overridden by Afrinic not being part of the problem.
Yeah. So Paul, your point is well made. Thank you for that. So I'll respond to that in a second. But before you launch into a TED talk, I want to give another opportunity. But I appreciate that. I think you've made your point well, and we'll come back to that in a sec.
Thank you. I promise this won't be another lightning talk at the microphone. My name is Nishal. For some of you that know me, I used to be the CTO at Afrinic. I'm not speaking as an Afrinic ex-staff member, but I'm speaking as somebody who used to be an operator of an internet service provider in the 90s. I know most of you in this room. I know how old you are, where your children are, where you've buried the bodies as well. So let me ask you, because I already know the answer to this, how many of you had more than a /19 in 1996? Yeah, I didn't think so, right? I mean, you know, aside from aside from like maybe 3 people that are sitting in this room, one of the founding reasons that we have an RIR for Africa is because there was recognition that policies that were used in other parts of the world were not necessarily applicable to networks in Africa. If you wanted an allocation out of Aaron in those days, and Aaron used to be the RIR responsible for us, you'd need to be able to justify a /19, which was a crap ton of space, and even with a much stronger rand, a crap ton of money to network operators that were starting up then. One of the first things that Afrinic did, and this is not Afrinic doing anything, this is the Afrinic community, and that's you, by the way. One of the first things that happened out of the Afrinic community was that the minimum allocation for LIRs, ISPs, like yourselves, dropped to a /22. And if you look at the allocation schema and how it was distributed to network operators in Africa, that improved dramatically after the start of Afrinic. I'm not here to tell you what you should think of Paul and Jan and whomever else is going to be coming to the microphone. You can have your corridor conversations. But I want to remind you that policies that apply to one part of the world are not necessarily applicable to other parts of the world. So when you come to the microphone and make quite silly statements like we don't need or blanket will fit, that's simply not true. One size does not fit all. Otherwise, I would be crammed into a size 28 pair of trousers that would fit me wonderfully, and so would most of you as well. So not one size for everybody. 2, thank you for acknowledging Afrinic staff for actually being quite brave in this. I think that people here think it's Afrinic staff that are fighting against them. That's not the case. For those of you that don't know, the guy running around with the camera, I can't see him. Where is he? Ah, there he is. Avi. Avi is Afrinic staff. He's unknown to us from Afrinic because he's good at AV and everything else that he does. So thank you, Afrinic, and thank you, Avi, for being here this week. And the third thing that I was asked to remind people about was that if you're a legacy resource holder, or a normal resource holder, obviously, you can still update your information in the Afrinic Whois database free of charge. There's this misconception that if you're a legacy resource holder, i.e. you got resources before the RIR system went into place, you can't go to Afrinic and update your information or any of the other RIRs. You absolutely can. And at least at Afrinic, they don't charge you for doing any of this stuff. So please, if you are a resource holder, a legacy resource holder in particular, you can update your information free of charge. Opinions? Lunchtime. Thank you.
Thanks, Nishal.
Hi, Graham from the internet. Just one small-ish question. The networks that have potentially the most to lose, I mean, in Africa, that's mostly the MNOs, but any of the big network operators, I know that 1 or 2 of them have kind of stepped up and got involved, but my sense is the vast majority of the really big guys are actually just not even caring. And in business leadership, I'm not seeing much interest in this issue. It's kind of like, well, go to legal and ask them if they can write a nasty letter, and that's kind of where it ends. And is that the same as what you're seeing? Are the big guys just completely ignoring it and hoping it'll go away on its own, or what?
Yeah, so I have to plead ignorance there because the companies that are involved are very private about their involvement. And so, but the sense I'm getting is that it's the vast minority of resource members. And it's, look, honestly, South African resource members make up a huge chunk of Afrinic. But it's the vast minority with people who care enough to have kind of stick their necks out and go, let's do something about this. Let's launch, let's, orchestrate the official receiver application. So I'm going to agree with you, but with an asterisk on that to say that I don't know what I don't know, because these guys don't want to talk about it if they litigate like that, unfortunately.
Yeah, and I think I've got a comment on that. I mean, let's face it. If you are prepared to stick your neck out on this, if you're a heavy resource, if you're a firm with /16, if you're a large ISP, you have a fiduciary responsibility to your company not to needlessly stick your neck out. So the only 2 groups of people that can really risk sticking their neck out on this, is either if you've got so much resources that your business, that it becomes an absolute business essential, or if you're a small company with a small block and you're prepared to be brave and stupid at the same time. I mean, that's the reality.
I tend to disagree with you because the fact is that the MTN, Vodacom, even Cell C, Telcom, they all need IPs.
Yeah, but my point is that it's in their interests to do things privately. It's not in their
Privately,
interest.
agreed.
What I'm saying is, you know, this is the conundrum that exists, which is that in order to do anything, especially to do anything publicly, you are taking a risk. You shouldn't be needing to take a risk, but the reality is that you are. So you either need to be very big and very prepared to bring out all of the guns that you've got, and you know, then be accused of lawfare, or you've got to be small, brave, and stupid. And I won't say where I see myself in this, but I'm certainly not very big.
With that, is there anybody from CETA here or at the conference while I have the microphone? If somebody from CETA is hearing this, please speak to whoever you need to speak to so you can reclaim the info plan block and vote. Please.
Okay. Guys, I'm needing to get the venue cleared out so we can set it for the next venue. So after these last two questions, we have to close it. Continue the discussions over lunch, please.
Thank you.
Otherwise, the hotel managers are going to come like try and attack me soon. So after this, no lightning talks, quick questions to the point, please.
Thank you.
Quick clarification on what you said just a while ago. People in the room should realize of Afrinic, 1/3 of all resources, IP addresses, are held by people in South Africa. 1/3 of all the revenue that Afrinic collects comes from South Africa. 1/3 of all the membership in Afrinic comes from South Africa. South Africa has a big part in this, and we should be able to, just as one country, do something about this problem.
Thank you.
So I'm Andrew from the internet. Africa has a problem that foreigners come in and take the resources and they run off, and they use it outside of South Africa and outside of Africa, and the foreigners, every other country, Europe, the United States, Australia, is happy to use those resources to the detriment of Africa. That's what's happening here.
Thank you for that comment. I don't quite follow, but appreciate your view nonetheless. Okay, folks, I'm going to close the session because we have been officially booted out. Thank you for your time, and I'll catch you over lunch and over beer.
Sorry, one item I was asked to remind people of. The social this evening, there's buses going after the last session. There's going to be 3 buses, one every 15 minutes. So once the session is finished, head to the bus and you can go to the final, to the social venue tonight.
Perfect. Okay. Good afternoon. I hope you had a good lunch. We're starting a bit late. I'm Max. I will be chairing this session. It's a session with two presentations that are also close to an area where I worked for a few years. When I worked at the Internet Society, I led the Community Networks project for 2 years. And the two topics we're discussing in the first two presentations are very close to where I was a few years ago. So we start with, and at the end of these two presentations, we also have lightning talks. So we start with Tim Genders, who's going to talk to us about connecting communities in Africa here.
You want this? Let me use that one. I can walk around then. Hi. Right, well, good afternoon, everyone. Let me stand up here. If we can have we got the slides? There we go, connecting townships. All right, so I've been with Project Seasway for about the last 7 years. And hopefully I can share with you some of the tricks and what we've learned out of working in these areas. So if we can shoot to the next slide. Have I got a clicker? There we go. Fantastic. Right, sorry, it's a little bit blurred. But this is an analysis I did very back of the envelope of some work that Cisco have done with their predictions of how much data people use in the world. And I sort of stripped out Africa from the Middle East and tried to get a sort of average per user, how much internet do we use each month. In Europe, it's around 50 gigabytes. In Africa, it's around 10, okay? What's really interesting, though, those deep blue lines, so the light blue is our fixed broadband, or let's call it Wi-Fi, and the dark blue is mobile data. And what fascinates me about this is that the amount of data your average African uses, the amount of mobile data, is about 7 to 8 gigs a month, which is similar to a European, okay? It's in the Wi-Fi, it's in the fixed access that Europe is 20 times more per person than Africa is. And there's a really simple reason for that, is that infrastructure hasn't been deployed effectively enough in Africa. So this is a really exciting slide in terms of where the market is. Actually, the market is not in mobile data in Africa anymore. That market, I think, is saturated because your average African uses the same amount of mobile data as your average European. Where the opportunity is in connecting up homes and connecting up those homes on fixed broadband basis. Now, it costs, apparently, according to Cisco, it's about 22 times more to connect, in the equipment cost, to connect someone with mobile data than it is to connect them with Wi-Fi data. I can't justify that number, I've just heard Cisco say it. But that sort of makes sense, because when I'm at home, I'm not going at 200 kilometers in a train and having to hand my data over from, one tower to the next tower. So it stands to reason that mobile data equipment is a lot more expensive. So there's a massive, massive opportunity, we believe, in connecting Africa up with fixed broadband. And it's a really, really important social need to do that as well, because without that, Africa gets once again left behind as a continent. Right. Let me go on to the next slide, which is where I've done another very back of the envelope calculation of, well, what's the market size? What can you expect out of this? Okay. So what I've done, I've taken ICASA's report that comes out each year, which is a really worthwhile report reading, and in there they've got their prepaid figures, which comes to basically our mobile band of 4 brothers, earn 56 billion rand a year out of prepaid mobile data or voice. I think it's more data than voice now. And that is spread roughly across, I think, across 14 million homes. There's 17 million homes in South Africa. Let's assume the top 3. They would sign you up on contracts. And then the next 14 million homes are in this prepaid market. So if we just simply divide 56 billion by 14 million homes, the maths actually comes to 333 per month per home. That's sort of how much revenue they're spending on mobile data as an average across the whole thing. So that's a very broad view of the sort of market pricing you can get out of these homes in South Africa. Okay. Now, here we have a very interesting slide of 2 places, both beginning with K, Katlehong and Kayamandi. Okay, both have got fiber. There is a marked difference between Kayamandi and Katlehong, and that is the fiber on the left has got lots of drops to the homes, and the fiber on the right doesn't have any drops to the homes. Now, the basic reason for that is, and when you're going into township areas, is to get the pricing model right, the package size right. Us, in our privileged world, get paid monthly, and therefore, when we're designing packages, seem to decide that monthly is the best way to bill, okay? Now, in a lot of the township areas, it's a daily hustle. Today you have money, tomorrow you don't. The next day you might have money again. The following day you won't. So I think it's absolutely critical to get daily billing mechanisms in place. And if you talk to anyone that's been, any ISP that's deployed in the townships with the Vuma product, the biggest nightmare they have is collecting the debts at each month. And what we feel very strongly is you actually just got to go pay as you go. So what the project in Kayamandi with Fiber Time did, which we got very involved with in the beginning of that project, our two philosophies that we put into that was drop a router as you go, drop as you go, and pay as you go. For me, that's critical because that upfront fee is too high. Whether it's 1,500 or whatever it is, it's generally too high. And also then your monthly fee of 400 is too high. Now, they may well pay 400 over the month, okay? But just don't expect 400 in any one go. If you want to sell cigarettes in the township, I haven't tried that myself, but what you do is you crack the pack open and sell them one by one. And really that's the key with, I think, with low-income deployments, is get a pay-as-you-go mechanism and get your package size that it's affordable, particularly for the youth, because they're the ones that are really repair. And that comes to R5 a day per device, an affordable amount. Now we're thinking, right, once you getting it into an area, instead of thinking about the revenue per home, why don't we think about the revenue per hectare? Okay? Because the revenue per hectare then looks at density of housing, and their buyers are really a tenth of the amount of revenue coming into Westville. So historically, for the first 10 years of fiber deployments, we focused on the Westvilles, on the Daneferns. We've got the founder of fiber into the home here, Paul Colmer, into Danefern. And we focused on those areas, okay? But if you look you down there, and I've done a spend of connectivity of around 2.5% of household income, and that's against a WEF white paper, because they say 4%, which includes your TV. Now, what's interesting, I gave you figures for a mobile spend in the previous slide, but actually we haven't even touched the TV spend. And what Fibertime have found in Kayamandi is that's the market they're aiming after, actually more than the mobile spend. The market is much more interested in Netflix and watching online TV than they are in saving on mobile data. So that's another whole lunch that you can eat of someone else's. And I think DSTV are struggling a little bit, from what I read in the press, there for the density of homes. But look at this, Kayamandi turns out double the potential of Westville on a revenue per hectare. Now, I know your capital deployment is potentially per home, but at the end of the day, fiber also is about density. And when the houses are dense enough together, fiber will really work. And we've actually got 2 businesses at least, and there's actually a lot more, but 2 I closely know about that are making a real success out of this. So on this, sorry, let me go back there. Yeah, sorry, this is a little bit small. So on this revenue, what we've done for the whole country, and I'm very happy to share with you these maps. We've got them up on the web, not publicly yet, but I've actually mapped out a revenue per hectare for every small area. So in the census, they have various categories, and a small area is about 200 homes. And then what we've done is we've mapped the ward municipality demographics and revenue per home data to create a view of our revenue potential per hectare. Now, sorry, it's a little bit small. In the north is Kayamandi, and you can see it's lighting up red as the highest revenue potential, whereas and that's beating a lot of the leafy suburb areas of Stellenbosch, which we've fibered up straight away. So what we've got is this resource that's available to people that want to go into townships to say, use what we've done. We're waiting now for the 2022 census data, and we can actually then show you the delta between 2011 and 2022, and show you the revenue potential per hectare of going into these areas. Right, let me move on. So I'm putting this up because I think this is the biggest problem, and I'm sorry I haven't got any golden bullet answers here, except for this. This is the area that we are struggling with the most, is that I've got my phone, I've got the Wi-Fi washing over me, I've got R5, and last time well, there's a little slot here, but I can't fit my R5 into the phone. And that's the biggest problem, is that we have got a very cash-based society. A lot of the citizens in these areas have got bank accounts, okay? But you might, thanks, 10 minutes. You might have noticed, if you drive past on a Friday, the queues at the ATM. And you might be thinking, why on earth is there a queues at the ATM? So what happens is on a Friday, they get, maybe as soon as they get paid, they'll belt it to the ATM and pull all the money out of their bank account before the loan sharks get it on Saturday. And so despite having bank accounts, we've still got this really cash-based society. That is a problem that we are needing to solve. We've been using products like VuluCoin. We've been hoping to get resellers going. Only about, in our view, only about 5% of the users want to be resellers, which is fine. We only get about 15% of the revenue through a reselling model. The rest comes from people buying the vouchers at flash machines and putting it in. But it's still clunky and complicated, and if we could get that user journey better, we feel that we'll get a lot more revenue. Now, one of the things with this, and we use two systems. We use PowerLinks from Sphinx, and we use Vulucoin for the payment gateway. And we had an epiphany just recently because we've always been worried about scale. You know, will our system scale? And what we've realized is actually we don't need to worry about scale. You can just have lots of user journey systems as long as you aggregate them up into a central BI database. That's all that matters. And really, there's only two aspects of data that we want, I feel is important. One is your session file from a Radius server. Who came on, when they came on, where they came on, how long, how much data did they use, and what package. You can get that from the Radius server's session file. And then the sales file is who bought, when did they buy, and how much did they buy. And you just marry those two together, and you can start getting really nice revenue pictures out. So we get revenue pictures out like this, so we can see exactly where our key revenue users are. And start like drilling in on that and trying to sell more in those areas. This is Lamontville. But the reason why I've put this slide as well is even on uncapped 5 Rand, pay as you might, eat as much as you like, not pay as much as you like, you pay 5 Rand but unlimited data. We're getting an average of about 1 gig to 1.5 gigs per month per usage. And that translates to, because we put a bit of free in there as well, we're earning about R1.50 per gigabyte out of our sustainable networks that we've experimented with. Now, for ISPs here, what I'd like you to do is go away, and maybe you can tell me what your figure is, that'd be really helpful. I want you to look at your total income and your total number of gigs that you spew out a month, okay? And divide the one by the other and work out what is your revenue per gigabyte. And I think you're going to see it comes in lower than 1.5, which means that there's a massive business opportunity here of connecting up our townships. And in doing that, you'll do a tremendous good to South Africa because it will really, really conquer this digital divide, help education, lots of positive good. And that's the end of my talk. Thank you.
Oh, wait.
Margins on cellular. And I think the cheapest at the moment, Telkom bought out a package for $6.99 a month with a 2 terabit data cap. Now, if someone's got a calculator, you can work out how much that is a gig. And I think it's something like 20, 30 cents. So there's a harsh reality out there that R1.50 is pretty damn good. Yeah? And, you know, the fact that they're charging 85 Rand a gig on prepaid because they're like robbing the poor, you know, and giving everything to the rich. It's the reverse Robin Hood model. You know? But yeah, so R1, and obviously they can make money on those contracts. Otherwise they wouldn't be doing it. They're not flushing the money down the toilet. So I believe R1.50 is a real number. And I think it's a good idea what Tim suggested, that you must go back to your own networks and actually work out what you're making per gig by the backhaul. Just an interesting point of how low it really can go.
Thanks, Paul.
Hi, Donald Jolly. Thank you very much, Tim. What do you see as your biggest challenge in terms of scaling this out to the rest of South Africa and Africa?
That cash flow cycle.
Sorry, what's that?
That cash flow cycle.
Just cash flow. So investment? So if someone comes to you with lots of money and says...
Yeah, there are investment engines out there. I guess for community networks is having the CA skill on board to be able to open up that investment. So I'd actually put investment as below as below trying to solve that cash flow cycle in these communities. Like, for example, we've got a network in Mpopomeni, which if you've ever swum the Mid-Mile Mile, is the township that you are swimming towards, okay? They've got like 33,000 people and 2 ATMs there. You know, it's just actually managing that whole flow of cash is probably, I would want to solve that problem before, and I think when that problem's solved, the investors are there. There's a lot of money that can be tapped into as long as you can prove the business model well enough. Thanks, Don.
Well, there is a question at the back. Yeah.
The cryptocurrency that you use, Vula Coin. Well, I'm not allowed to call it a cryptocurrency, but the token that you use on the network. How's that worked out for you? Is it working well? And did the outages on the Solana network and stuff affect you guys? How do you deal with that? And where do you see that going for you in future? Thanks.
Thank you. Yeah, look, VulaCoin, there's quite a few companies that have spun out of Project Isizwe down the years. One is Namola, which, if you've seen that as a safety app. VulaCoin was another one that span out of us. I think we made a bit of a mistake in going sort of a different currency. We should have made it Rand, but I think there were some regulatory issues around the wallet and Rand and that sort of thing. So I think we introduced a bit too much unnecessary complexity there. Stability has been all right. I mean, that outage, unfortunately, networks have outages and it went alongside a bit of load shedding and that sort of thing. So they've been great in the sense that it's working. Okay, I still feel that user journey we can improve on, and I feel that's where a lot of our work needs to happen in that. And I think the more simple you make it, the better. Yeah. Any ideas on that front are more than welcome. The other thing, actually, I want to put out there, if anyone's got a system that I can show an advert at the end of it, I am looking for a system that can do an advert at the end of it without one-time passwords with SMSs. Please come and see me, because I really would like to deploy it quickly.
Well, thank you very much. As we've run out of time, we don't have time for any other questions, but here's a token of appreciation for presenting. So, thank you very much. Now, next we have Sean Pater, who's going to tell us about network equality for the rural areas as well. Yeah, that works. And you have the clicker. Okay.
Thank you. Before I introduce myself, I'm going to talk about community networks in a very different perspective from what Tim just presented to us. I want you all to just get a glimpse of the collage in front of you. And take note, I've blurred the picture of the little boy because I can't republish pictures of kids. But this is the terrain on the top right corner, sitting in a field, pretty rural, hills, typically the type of dwelling he might live in. And this is the wireless network access point. And so he and his friends are sitting in the field, breathing off, walks a dusty road to school. The school has no digital facilities. It has a roof, they have teachers, but they're very far away from the digital world you and I are used to. They're very far away from the type of urban environment that we live and work in. And this pretty much if you can sink your minds around this image, is the scenario behind which the community network initiative that I'd like to present to you this afternoon is framed into. I'm Sean Paffer. I'm a professor at the University of the Western Cape of Information Systems. I've been working in the ICT and public domain space for many years. All of my work is around the space, doing academic work and influencing and advocating for policy shifts in the country and in the region. And so this afternoon, it's my pleasure to present to you about Zenzileni networks. And very different from the presentation we heard just now, because the problem of community networks in a typical rural area is very, very different. And we can't even talk about per hectare cost, etc. And it's quite different. And just to remind ourselves the problem context in South Africa, we have some historical policy milestones. We're about 21 years since the first World Summit, 17 years since the South African ISED plan, launched by then late Minister Kasaburi, 11 years since SA Connect, 7 years since our national ICT policy white paper, in which I was quite integrally involved. But yet we have very large swathes of underserved communities, especially in rural South Africa. Yes, we're making quite a bit of inroads and projects like Sizwe, etc. And in some urban and peri-urban communities where Tim and Sizwe are trying to make dents into. But the problem, the historical digital inequality is historical and is depicted both in geography and the perpetuation of income status, wealth, and poor. And we have, I would argue, I think, good policy frameworks, but implementation lethargy, digital migration, SA Connect are some shining examples of implementation lethargy in the country. Census 2022 is the most recent indicator that upholds where we are. Yes, there's been a lot of shift in terms of penetration, but I'm coming to a point of penetration just now, versus outcomes. And as you can see, 64%, 64.8 versus 21.1 in 2022 at a household level. So quite a big shift in terms of households with no access to the internet. But looking at the main access to internet, we can see that 21.1% at a household level in 2022 census still do not have any access, and a large part of these people are in rural South Africa. And at 60.5%, cell phone is the main kind of use in many households to access the internet. So the persistence of the digital inequality, we can have no argument about it, and the main contention around this problem context for me is the plight of rural South Africa. Now, I've had a lot of people who work in the space, and my fellow academics, some of them have argued with me that, there is no more a digital divide when you look at the figures and you look at the penetration of mobile and you look at the SIM ownership in the country. And so the question really is, what is the real effect of mobile penetration, including questions around two things: affordability, big question, and task suitability. It wasn't my intention to show you things out of the academic literature, but just as an example, something that I've done a lot of work with this is a model called Technology Task Fit. And a lot of the work I've done in public access centers, in townships and other places, show that the mobile phone is restrictive for many of the tasks that underpin socioeconomic development. In fact, in many of the township public access centers, in libraries and cyber cafes, such as Silulelo Uto, I think, I forget the name, here in Khayelitsha and other townships, the most common task that youth are performing in these public access centers are the writing up of CVs to apply for jobs. And many of these socioeconomic tasks are prohibitive. So this model, I'm sure you all know very well, which is an InfoDev-based model of of economics in telecom space. But the true access gap, which is where rural South Africa, which represents rural South Africa, the poorest of the poor in the country, needs different thinking and needs different models. Everything that's happening, including the most recent types of policy developments, the intentions in the electronic communications bill, which was out for comment last year, indicates that we're still not going to get to this true access gap. So, community networks, a response to the persistent digital divide. My idea, or the idea of community networks in this presentation, is quite different from what you've just heard. There's been increasing advocacy and policy around community networks, so such as at the level of the ITU, and then our own ECA amendment bill. We've been, as Zenzileni, advocating for policy shift for many, many years and at every opportunity. And last year was the first indication of this, with a definition and other types of amendments proposed in the bill. As you can see, I've just copied out just the part about providing for a definition for community networks in the amendment proposed for the bill. And there are several examples of policy implementation in favor of community networks around Africa, Uganda, Kenya, Zimbabwe, to name a few, elsewhere in the world, such as Mexico, in the UK even, formal shifts and realization of needing to do things differently in some parts of the country. So therein is Zenzileni, the project that I'm involved in. I'm the chair of the board, but it's not just being a chair, it's more or less, I suppose, like a second job alongside my academic work. To me, it presents a real living lab, an idea in which to explore, to understand the realities of network provision, of trying to get outcomes from the network, and to use it to influence both research, knowledge production, and policy. So Zenzileni means do it yourself, and it's a not-for-profit company spun out from the University of the Western Cape, which we registered in 2017. Its roots lie in the initial PhD work done by my colleague, now with the Association of Progressive Communications, Dr. Ray Moreno, in the period 2012 to 17. And so it is an approach that says, let's not just look at the network layer, but look, this is what I call my community informatics framework, from access to development. So to consider, and this is especially true of impoverished communities, we cannot just deploy a network, you've got to think about the bigger picture. So from access to stimulation of demand, to ensure that the access converts into empowerment, self-motivation, and what we call then the social appropriation of the technology eventually. Impacts on the economy. Zenzileni has received several awards for what it tries to do, and these are just some examples of the awards that have been given to us over the years. So the model addresses, if you look at the ICT white paper of 2016, under the section on universal service and access, it talks of the pillars of universal access, and the model tries to address all of those pillars to realize universal access, which is beyond just set of infrastructure, but affordability, content, skills, awareness, acceptance. The earlier definitions of universal access, we've only had one set of definitions in the country, by the way, even though the Act provides for definitions, and that was in 2010. So a snapshot of who we are, well, from 2012 to 13 to about 2018, I would call the research and investigation phase, and the real understanding and piloting of the model into a real world phase started from around 2018 onwards. So this is Mankosi, the founding community in which the first instantiation of the network was born. 12 villages, 580 households, about 3,500 people. So you can get the picture, the issue of density and the like and business model when you're trying to service typical rural South Africa changes. So we cannot think in the common ways in which we think of telecommunications business models. It's 2.5 hours drive, 86 kilometers over poor roads from Mthatha, most of which have no tar. Community has very poor access to services. There's low levels of education, so it's typical of demographics. As you drive over the hill, this is the type of scenery that confronts you. But for many of you who are network engineers here, you will understand the plight of trying to provide services to terrain that's typically like this and so far away from the nearest exchange point, which in this case is in Mthatha. In 2015, with the research that was done there, we found that 86% of people use their mobile phone on a weekly basis. But from all of the data that was collected in 2015, the most important one was that even then, where voice was still important, 15% of them sacrificed food to use mobile phone services. And that was purely to keep in contact with family members who were migrated to the cities to work. In the first instance, the first round of the project, or the first idea of the project, was to seed a local ISP, a local cooperative, and this was the local cooperative, so registered and will have a network, have an exemption from ICASA to operate a network. But importantly, that the start of the network, and we have plenty of evidence of this. This is Tata David Lukosi, a cooperative board member. In an interview with him, one of the things he said was, I didn't know that you could get a little bit of money without having to go outside the community to work hard. Because these are communities who for many years where you could only earn income or have any kind of economic development by leaving the community. And through the services, they began to realize the potential of actually trying to have economic growth in the community. So local skills, network installation, and I don't have a lot of time to get into the nitty-gritties of everything, but essentially it's about working with the community, providing them with skills to develop the network, install the network, and in fact, just to say, these are probably not the more difficult parts of the project, giving skills and teaching people how. But this is just an example of type of the spin-offs. These ladies, by the way, in the background, you'll see there what's called a solar learning lab that we built with the funding from Dell Foundation through Computer Aid International. On their own, and at their own request, with no prompting, asked to want to watch YouTube videos about growing food in a garden. They started this food garden and are now earning a living out of it. The fact that the basic sustainable livelihood agriculture in many rural areas has been lost many years ago. So having the internet, and there's many other possibilities and examples of this. That's the solar lab, and now people are doing ICDL, etc. Now let me just take you through some elements of the model. At a technical level, the backbone uses the wireless backbone unlicensed frequency 2.5 and 5 gigahertz, but it runs all the way from Mthatha over the 86 kilometers towards the coast, and the green shows you the potential areas of service, and those are some of the high sites that we have there that you see in the map. Speeds are fairly low, we can imagine, with the type of network, but sufficient at least for the basic types of services and activities that they need in the community. Currently, the numbers of assets we have across there's just a new community we've started in, total of 205 pieces of equipment, and we've spent 710,000 over the years for the type of network that we have built. From an organizational and operative structure, initially the idea of community-owned, and this is where we had to rethink the model. Community-owned at ISP, we found the difficulty of the cooperative running a local business to be not sustainable nor successful. This is some of the evidence where we did an assessment of business, legal, and other types of skills, and it was found not to be favorable. So we had to rethink the strategy of what do we mean by community-owned. And so community-owned then became into a micro level in which we seed resale and voucher reselling and hotspot ownership with local people in the community, and that's a local ownership level. And then the not-for-profit company, which is what the board of which I'm the chair, is a spin-out. At the moment on the board, UWC, Ellipsis, APC, and others sit, and this is, as a not-for-profit, we coordinate the affairs and run the business, seeding entrepreneurs who do the sales and voucher and hotspot maintenance in communities. So what's different in this model? Well, the average operator is profit-driven, is keen to sell data and voice. In our model, the access layer is concerned with affordable and underline affordable, and the model is concerned with uptake and use. So in our work, we do not just deploy the network, but find partners with whom they would come into what I call catalyzing the digital ecosystem. And by doing that, our data shows that the income and expenditure, and if you look at the orange part, you'll see that over the years, this is the amount of expenditure, local expenditure, that gets retained, because the local entrepreneurs now who are selling vouchers for the hotspots retain their commission, and that commission stays in the community. And the not-for-profit company takes a portion of it simply to try and run the community. So there's a three-tiered model, and the three-tiered model means you could start selling vouchers, you could then add value-added services to your hotspot, or you could even then take over an entire small area for and become a mini ISP if you like it. This is the structure of the organization, of course, well, which has a lot more potential. It's very, very, very slim in the way it operates. From a legal and regulatory perspective, both cooperatives in the first two communities have PECN exemptions from ICASA. As the NPC, we have ECNS licenses for two districts, Amatola and OR Tambo, and you can see the size there. And when we start looking at the size of these two municipalities, then, Tim, we can start beginning to think a little bit in the way you are thinking of township connectivity. From a services perspective, we have ECS reseller exemptions as the NPC, and most recently, as of last year, we have a ECS non-profit exemption from the regulator. The implications, we are able to transition to a new model as opposed to when we started because of the cooperation of ICASA with this, and we must thank the regulator for being very supportive of what we are doing. And we haven't yet, but we may have to pay for regulatory compliance. We're waiting to see what comes out of the new bill. From a financial perspective, what do we have? We have 74 hotspots and counting at the moment, of which people buy vouchers for 25 Rand per month. Very different business model from ECC. And that's at the lowest possible speed. But at this possible speed, because the uncontended network, they're able to do most of the basic things that they want to do at hotspots. There are cap services to contract clients, and this is at competitive pricing, but most of these are pretty decent figures for 3 small communities that we are servicing. So I want to get to this part. We have a business model canvas for social enterprises that maps onto what, and remember, although we are talking about Zenzileni, we are actually trying to demonstrate what is possible to connect rural areas in the rest of the country. So we have a business model canvas that shows both from the network layer to social appropriation of the technology. Looking historically at our finances, we've spent about 3 million Rand in 4 years, a lot of which was funded through grants. As compared to what's been funded from the USEF in the Eastern Cape, in the areas where we operate, about 70 million rands funded from the USEF to other operators to date, nothing to show. Money spent and nothing connected. We've spent about 3 million rands and still are providing services to communities. So we argue that we have evidence that in the true access gap, that there must be an ongoing subsidy. But we also have evidence that if you can seed the initial startup, then our model demonstrates that you can actually run a sustainable business on a not-for-profit basis. And we believe that the model demonstrates we can do this if there is a will, because we don't believe that even with the most recent spectrum auctions, with the obligations and the like, that the types of communities we are talking about in rural South Africa will actually be serviced. So I'm going to, Chair, just skip ahead to we have demonstrated, by the way, a lot of potential. We've connected a public hospital. We've shown how the doctors there, thank you, 5 minutes, how the doctors in the public hospital have improved the way they do their work prior to not having a network. We have the potential to provide services almost immediately to many public sector organizations in the areas and beyond, if we were able to scale, but it comes with its own challenges. So just the yellow pins there, for example, is an indication of the number of schools we could potentially communicate. Remember, the USAF has spent over 70 million rands in this region already. None of these schools have sustainable connections yet. Okay. So what are some of the areas of need? And I think we need strategic partnerships to continue operating. Certainly, I think from a funding and sponsorship perspective, there are opportunities to partner with models like this, opportunities for BBBEE scorecards. As a not-for-profit, people who give us money have tax-deductible donations. Now, I'm not talking about this in terms of just funding for Zenzileni, but if the model had to be replicated. From a skills perspective, partnerships to help develop further technicians, train more younger people, internships for our current and future network technicians. Partnerships, support to create partnerships with the public sector who could become formidable anchor clients. Our network operations center, we'd like to improve it from 80 to 99%. Currently, we are sharing premises at Walter Sisulu to find a better premise for that. And as I have about a minute left, we also have just done a lot of work to pilot alternative models. I wouldn't call it MVNO, but let's say MVNO-like model for rural South Africa, but for which we would need a spectrum allocation to properly pilot it. And I have a lot of hope for such types of evolving models. So yeah, I will stop there, Chair. There's quite a mouthful to share about so many things that we've learned in this many years of exercise, but be happy to take questions.
See someone going to the microphone, so.
Hi, this is Andy Rabaliati. I've been to the Mandosi thing. It's very impressive, and I think it's a fantastic job you're doing there. What do you do? Is it a MAC level authentication, or do you have a user password authentication what they pay for in order to get access?
So it's a MAC level. There's no use, but there's room to also evolve and improve that model. What I didn't also point out is that there's a huge need around the payment system as well, because rural works mainly in cash, and that's a big challenge. So we haven't innovated yet.
Hi, I'm Guy Hels from Tenet. Fantastic work you're doing.
Close to the microphone.
Really mirrors some stuff that we were doing when I was at Rhodes University. And it's really good to see other people doing the same sort of thing. There was a challenge issued to the people in the room earlier, and I want to issue a different challenge based on what you said. The majority of poor South Africans are reliant on mobile phones. The thing is that the mobile phones that they have in their hand look nothing like the mobile phones in your hand right now. Go out to PEP or Ackermans or something like that, buy a 500 Rand cell phone, smartphone, and that is the lived experience of the majority of the poor South Africans in this country. and then try and write a CV on it or do something like that. And then you start to appreciate really why projects like this are phenomenally important in this country.
Thank you. Okay.
I see no other questions, so let me give you a token of appreciation. So next up we have two lightning talks. Yune Okal, so are you in the room? Did I see a hand raise? No. Okay, then let's try with Bob Ochieng. No? Bob? Oh, so you're Yune. No? Ah, okay. So new generic TLDs. Yeah, take the stage. There's the clicker there. The second one. The second one. Yeah, they're coming. Give it a moment.
Okay, so thank you very much. I know our time is very limited on this segment. So allow me to speak to you on a little bit different topic, maybe not very different, for the next 10 minutes. And my colleague, June, will take another maybe 10 minutes to speak about two other topics. I'll talk about the new generic top-level domain names program. My name is Bob, and I am leading the implementation of the new generic top-level domains program from ICANN. And really today, we want to share with you very quickly a very high-level summary on where we are with this program, and especially key milestones and dates that probably for those who would be looking forward to participate in this, from different viewpoints or different capacities, might want to keep an eye on. So as you know, the new GTLD space has been expanding for the last several years now, for those of you who have been following. And so let me just see how this works. This goes to next. Okay. Yeah, so this will be very quickly. Okay. So this side. Maybe the battery is low. Okay. So we all know after 2012, something happened, and you were able to have the same domain names, first of all, for example, in other writing scripts, for example, so Arabic, Chinese, or Japanese. So you could have, .NET, but in